In 1981, astronomers pointed their telescopes at a dark patch between constellations and found nothing. Absolutely nothing. A sphere of emptiness 330 million light-years across, where 2,000 galaxies should exist but only 60 remain. We call it the Boötes Void, and for decades we thought it was just empty space doing what empty space does. But recently, we detected something inside. Something that moves, something that pulses with energy, something that, according to every law of physics, cannot exist in a place that empty. If you enjoy unraveling cosmic mysteries with us, hit that like button and subscribe. What we found hiding in the void changes everything. Prepare yourselves. We begin. Picture this. 1981. Robert Kirshner and his team are mapping galaxy positions for what should be routine work. They expect to see galaxies scattered everywhere, the way stars fill the night sky. Instead, their instruments show a gap, not a small gap, a region where galaxies just stop existing. They check their equipment 3 times. The readings stay the same. They expand their survey outward, following the edges of this emptiness. It keeps going and going, until they realize they are staring at something 330 million light-years wide. To understand that scale, imagine our entire galaxy as the size of a quarter. You would need to line up 33 million quarters, edge to edge, to cross this void. Light itself, traveling at 671 million miles per hour, needs 330 million years to make the journey from one side to the other. The team names it the Boötes Void, after the constellation where it hides. They calculate how many galaxies should occupy this volume of space, based on the average cosmic density. The answer comes back, around 2,000 galaxies minimum. They count what actually exists inside. 60 galaxies. 60. That means 97% of the galaxies that should be there have vanished, or never formed in the first place. The discovery sends shockwaves through astronomy because voids this empty are not supposed to exist according to our models of cosmic evolution. Matter should be distributed more evenly throughout space. Something carved out this region and left almost nothing behind. But here is where the story takes a darker turn. Those 60 galaxies that remain are not randomly scattered. They cluster along the void's edges in thin chains, like they are fleeing from something at the center. Like they know better than to venture too deep inside. When Kirshner publishes his findings, other astronomers rush to point their instruments at this region. Every telescope confirms the same thing, a sphere of almost perfect emptiness hanging in space. Most scientists assume it is just an unusual statistical quirk, a cosmic accident. The universe occasionally rolls the dice and comes up with weird results. Except the void keeps revealing stranger properties. The few galaxies inside show unusual traits. Their light spectra look wrong. Their velocities do not match predictions. Something about the space itself seems different. And 40 years later, we detected energy signatures coming from deep within that emptiness. Patterns that repeat. Structures that should not form in a void. The question shifts from why is it empty to what exactly is hiding inside. Because empty space does not emit signals. Empty space does not organize itself into patterns. Whatever we found in there is doing something. And we need to understand what happens next before it is too late. Our current model of the universe works like a recipe. You start with the Big Bang, add dark matter and dark energy. Sprinkle in regular matter, and let gravity do its work for 13.8 billion years. The result should be a cosmic web, filaments of galaxies connected like spider silk, with smaller voids scattered between them. The largest voids in this model should measure around 150 million light-years across, maybe 200 million in extreme cases. That is what the math predicts. That is what most of space looks like when we observe it. The Boötes Void measures 330 million light-years across. It doubles the maximum size our physics allows. This is not a small discrepancy. This is like predicting a human can grow 6 feet tall and then finding someone who stands 12 feet high. The difference demands explanation. Here is why it matters. In the early universe, matter distributed almost evenly in all directions. Tiny quantum fluctuations created slightly denser and slightly emptier regions. Gravity pulled matter from emptier zones into denser ones. Over billions of years, this process carved out voids surrounded by walls of galaxies. But gravity works at a specific speed. It can only pull matter a certain distance in the time since the Big Bang. Run the calculations backward, and you find that creating a void this large requires either much more time than the universe has existed, or much stronger forces than gravity can provide. Neither option makes sense. The universe is not older than we measured. Gravity has not changed its strength, yet the void exists anyway, sitting there like a hole in reality that violates the rules. Some physicists suggested dark energy expanded this region faster than normal. Dark energy pushes space apart, so maybe it concentrated in this zone and inflated the void beyond typical limits. The theory sounds reasonable until you check the math. Even with maximum dark energy concentration, you still cannot reach this size without breaking other cosmic constraints. Others propose this region started with much less matter than average, a statistical fluke on a massive scale. But the probability of that happening calculates to essentially zero. You would need to win the cosmic lottery billions of times in a row. The truth is, we have no standard explanation that fits. The void should not exist according to our best physics. Yet, every telescope that looks at this region confirms it does exist. Which means either our understanding of cosmic evolution is wrong, or something else happened here that we have not discovered yet. And recent observations lean heavily toward that second option, because voids are supposed to be passive. Empty regions do not do anything except exist. They certainly do not emit organized energy patterns. But the Boötes Void is doing exactly that, which suggests it is not just a void. It is something far stranger wearing a void's appearance. Stand outside on a clear night and look up. Every star you see belongs to our galaxy. Even the faintest pinprick of light sits within 100,000 light-years of Earth. That is our neighborhood, our local reality. Now, multiply that distance by 3,300. That is the width of the Boötes Void. It swallows 330 million light-years of space. To cross it, you would need to travel at light speed for longer than complex life has existed on Earth, multiple times over. Here is another way to grasp it. Take our Milky Way galaxy with its 200 billion stars. Place another galaxy just like it 50 million light-years away, then another, then another. Keep going until you have positioned 2,000 massive galaxies in a sphere. Now delete 97% of them. Leave only 60 scattered around the edges. That is what we are looking at. The void contains enough empty space to hold thousands of galaxy superclusters, regions where millions of galaxies should be gravitationally bound together, forming the largest structures in the cosmos. Instead, we find darkness, silence, a cosmic dead zone that stretches beyond human comprehension. Light from one edge of the void takes 330 million years to reach the other edge. When that light began its journey, the most complex life on Earth consisted of single-celled organisms, no plants, no animals, no humans. By the time the light completes its crossing, entire species have evolved and gone extinct multiple times over. This is not just big. This is functionally infinite from a human perspective. You could fit 75,000 Milky Way galaxies side by side across this emptiness. You could lose our entire local group of galaxies inside it and never find them again. The void could swallow every galaxy humans have ever observed through telescopes and still have room left over. And yet, despite this incomprehensible scale, astronomers mapped the entire structure in just a few years. How? Because emptiness has a signature. Where galaxies should create light, This region shows darkness. Where matter should bend space, the void leaves space flat. It stands out like a missing tooth in an otherwise complete smile. But size alone does not explain why scientists keep studying this region. Plenty of large structures exist in space. What makes the void terrifying is not how big it is what that size represents. The void shows us that our universe can create regions where the normal rules simply stop applying, where cosmic evolution fails to produce the expected results, where something fundamental breaks down. And if it happened once, creating this impossible emptiness, what stops it from happening again? What prevents other regions from developing the same properties? What if voids like this are spreading? The answer to that question came from an unexpected direction, from the 60 galaxies that refuse to leave. Gravity does not work alone in shaping the universe. It has an opponent, a force that pushes instead of pulls. We call it dark energy, and it makes up 68% of everything that exists. Here is how the battle plays out. In the early universe, matter distributed almost uniformly in all directions. Tiny variations in density appeared, no larger than 1 part in 100,000. In slightly denser regions, gravity won. It pulled nearby matter inward, creating the first stars and galaxies. These zones grew denser over time, but in slightly emptier regions, the opposite occurred. With less matter present, gravity weakened. Dark energy, which pushes uniformly everywhere, began dominating instead. It shoved the remaining matter outward, evacuating these zones even further. The emptier they became, the stronger dark energy's influence grew. This process created voids. Think of them as anti-galaxies, places where dark energy beat gravity in their cosmic tug-of-war. Matter fled these regions, piling up along the edges and forming the walls of galaxies we observe today. The interior became increasingly empty as time passed. Most voids grow slowly. They start small and expand over billions of years as dark energy pushes matter away. Their growth rate depends on their initial emptiness and the density of surrounding space. Run the simulations, and you get a predictable distribution. Lots of small voids, fewer medium voids, almost no large voids. The Boötes Void violates this distribution. It sits beyond the size range our models predict. Even accounting for maximum expansion rates and optimal starting conditions, you cannot grow a void this large in the time available, unless something else happened. Some cosmologists propose the void formed from a bubble collision in the first moments after the Big Bang. During cosmic inflation, space expanded faster than light for a brief instant. If two expanding bubbles collided and merged, they might create an underdense region that grew into an enormous void later. The theory has merit. Bubble collisions could explain the exceptional size, but it requires precise timing and positioning that seem unlikely, and it does not explain the other anomalies we detected. Other scientists suggest the void formed from primordial quantum fluctuations scaled up to cosmic size. Imagine a region where quantum uncertainty created slightly less matter than average. Over billions of years, that tiny difference amplified until it produced this massive emptiness. Again, possible, but the probability calculations come back unfavorable. Random chance almost never creates outliers this extreme. The truth is, we keep proposing theories because the standard explanation fails completely. Voids are supposed to be simple structures. Matter leaves, dark energy dominates, the region stays empty. Nothing complicated, yet the Boötes Void refuses to behave simply. It formed too large. Its interior shows unexpected activity. The galaxies inside display bizarre properties. Everything about it suggests something beyond normal void formation occurred here. And when we detected those energy patterns last year, the debate shifted entirely. Because now we are not just asking how the void formed, we are asking what moved in after. Most voids contain some galaxies. A few dozen scattered through the interior. They form early in cosmic history before the void fully evacuates, or they wander in later from surrounding regions. Nothing unusual about their presence. The 60 galaxies inside the Boötes Void are not like that. They break multiple rules simultaneously. First, their positions. They avoid the void's center completely. Instead, they cluster along the edges in thin filaments, like beads on a string. This distribution makes no sense gravitationally. If they formed naturally inside the void, they should spread more evenly. If they fell in from outside, they should sink toward the center where gravitational potential is lowest. Instead, they stay near the walls, like they are being held there by something we cannot detect. Second, their ages. Spectroscopic analysis reveals these galaxies are old, very old. They contain ancient stars that formed when the universe was much younger. Most galaxies in voids are small and young, having formed recently from leftover gas. The Boötes galaxies look like mature elliptical galaxies that belong in dense clusters, not empty voids. How did old, massive galaxies end up in the emptiest region of observable space? Did they migrate here? Were they pushed? The motion patterns do not support simple migration. Something else placed them in these specific positions. Third, their velocities. Galaxies move through space at speeds determined by local gravitational fields. Measure a galaxy's motion, and you can infer the mass distribution around it. The Boötes galaxies move wrong. Their velocities suggest they feel gravitational forces from matter that is not there, matter we cannot see. You might think dark matter explains this. Dark matter fills most of space, providing invisible mass that affects galaxy motion. But voids specifically lack dark matter. That is part of what makes them voids. The dark matter evacuated along with regular matter. Yet the galaxies inside Boötes behave like dark matter surrounds them, like the void is not actually empty. Fourth, their light. Every galaxy emits radiation across multiple wavelengths. Visible light, radio waves, X-rays. The spectrum tells us about the galaxy's composition and activity. The Boötes galaxies show spectral anomalies. Specific wavelengths appear dimmer than expected. Others appear brighter. The pattern does not match any known galaxy type. Some astronomers propose the void's emptiness affects how light travels through it, altering what we observe. But light does not change properties just because it crosses empty space, unless the space itself has unusual properties. Which brings us to the most disturbing observation. The 60 galaxies are not randomly oriented. Their rotational axes point in similar directions, not perfectly aligned, but statistically improbable. Like they are all responding to the same external influence. Galaxies form from collapsing gas clouds that rotate randomly. Their orientations should show no pattern across large distances. Finding alignment suggests a force acted on all of them simultaneously. A force strong enough to influence their formation or alter their rotations afterward. We have no idea what that force could be. Nothing in standard physics operates on such scales, yet the alignment exists in the data, confirmed by multiple independent surveys. The 60 galaxies are not just survivors in an empty void. They are markers, clues pointing towards something we have not discovered yet, something that organized them, something that keeps them in place. And recently, we found it starting to wake up. Galaxies age like living things. Young galaxies burn bright blue, filled with hot, massive stars that form rapidly from abundant gas. As they mature, the largest stars die off, leaving cooler, redder stars behind. The galaxy's light shifts toward longer wavelengths. Eventually, star formation slows or stops completely. The galaxy becomes a red, dead elliptical filled with ancient stars. This process takes billions of years. You can determine a galaxy's age by examining its light spectrum. Blue light means young stars forming now. Red light means old stars formed long ago. The ratio tells the story. The 60 galaxies in the Boötes Void shine predominantly red. Their spectra show populations of stars 10 to 12 billion years old. These galaxies finished forming stars billions of years ago and have been coasting through time ever since. They look like retirement homes for stars. Now, here is the problem. Galaxies like this form in dense environments. When you pack many galaxies close together in a cluster, their mutual gravity heats the surrounding gas to millions of degrees. This hot gas cannot cool down and collapse to form new stars. Star formation shuts off. The galaxies age rapidly and turn red. Voids have the opposite conditions: low density, cold gas, minimal interactions between galaxies. These conditions favor ongoing star formation, young, blue galaxies, not ancient red ones. So how did old elliptical galaxies end up inside the most empty region of space? The standard explanation suggests they formed elsewhere in dense clusters, then somehow migrated into the void. Galaxy migration happens. Gravitational interactions can fling galaxies across vast distances, but the math does not work. To reach the void's interior from any nearby cluster, these galaxies would need to travel 50 to 100 million light-years. At typical galaxy velocities, that journey takes several billion years. During that time, they would pass through regions with fresh gas. Star formation would reignite. They would not stay pure red. Yet they are pure red. No signs of recent star formation. No blue young stars mixed in. They aged in place, not during a long migration. Some scientists propose these galaxies formed inside the void when it was younger and denser. Before dark energy evacuated the region, enough matter existed to create these mature galaxies. Then the void expanded around them, leaving them stranded. This theory faces timing problems. The void would need to expand rapidly after the galaxies finished forming, before new gas clouds could create younger galaxies nearby. The sequence requires precise coordination that seems unlikely. Others suggest the galaxies formed normally elsewhere, but an unknown force transported them into the void quickly, fast enough to preserve their old stellar populations. But what force moves entire galaxies across cosmic distances without leaving traces? We have no mechanism for that. The final, most disturbing possibility is that these galaxies did not age naturally. Something inside the void accelerated their evolution. A process or field that speeds up time locally, causing stars to live and die faster than normal. The galaxies would appear old because they experienced more time than the universe's actual age allows. This explanation sounds like science fiction. Time does not flow at different rates on cosmic scales. Except it does near massive gravitational fields like black holes. And it does in expanding space affected by dark energy. General relativity permits time dilation under the right conditions. Could the void create those conditions? Could its extreme emptiness warp space-time enough to affect how time passes inside? We have no evidence for this, but we also have no better explanation for why these galaxies look the way they do. And if time flows differently in the void, that might explain the signals we started detecting, patterns that repeat with clockwork precision, as if something inside operates on a different temporal rhythm than the rest of the universe. Something counting down to an event we cannot predict. 3 years ago, astronomers using the Hubble Space Telescope pointed their instruments at one of the 60 void galaxies. They planned a routine observation to measure its stellar populations. Instead, they recorded something nobody expected. The galaxy dimmed. Over the course of 6 hours, its light output dropped by 8%, then slowly recovered to normal brightness. The change occurred smoothly, following a curve that resembled an eclipse, as if something passed in front of the galaxy, blocking our view. The team assumed they caught a random occultation. Maybe a foreground object drifted into the line of sight. They flagged the observation as potentially contaminated and moved on. 2 months later, the same galaxy dimmed again. Same magnitude, same duration, same curve shape. This was not random. This was periodic. The astronomers expanded their survey to include all 60 void galaxies. They set up monitoring programs using multiple telescopes, watching continuously for weeks. What they found sent chills through the astronomy community. 17 of the 60 galaxies showed dimming events, not all at once, not randomly. They follow a pattern. Galaxy A dims, then 3 days later, Galaxy B dims, then 5 days after that, Galaxy C dims. The sequence repeats every 78 days like clockwork. 17 galaxies blinking in a specific order that never varies. No known natural process creates this behavior. Eclipses happen randomly based on orbital mechanics. Variable stars pulse independently of each other. Dust clouds drift through space without coordination. You cannot get 17 galaxies separated by millions of light years to dim in sequence unless something connects them. The dimming itself is unusual. 8% loss of light sounds small, but it requires an enormous object to block that much light from an entire galaxy. We are not talking about a single star being eclipsed. We are talking about the whole galaxy dimming together. The obscuring object would need to be larger than the galaxy itself, spanning hundreds of thousands of light years across. Nothing that large exists in the void. The region is empty by definition. Even if you compressed all 60 galaxies into a single object, it would not be large enough to block 8% of another galaxy's light. Unless the obstruction is not a solid object. Some researchers propose we are seeing interference patterns from dark matter waves moving through the void. Dark matter can clump and flow like an invisible ocean. If waves moved through the region in sequence, they might gravitationally lens the background galaxy's light, creating the dimming effect. The theory requires dark matter to behave in ways we have never observed before, forming coordinated waves across millions of light years, maintaining perfect timing for years without dispersing. It is possible, but it stretches our understanding of dark matter to the breaking point. Another hypothesis suggests we are detecting megastructures, artificial constructions built by advanced civilizations. If intelligent beings engineered enormous arrays of objects in specific orbits, they could create periodic dimming events. This explanation appeals to those who search for techno-signatures. The pattern looks artificial, too precise to be natural, but it requires a civilization capable of engineering on scales that dwarf anything in human imagination. Why would they build something that dims galaxies? What purpose does it serve? The most troubling interpretation is that the dimming reveals something moving through the void, an entity or phenomenon that passes in front of galaxies in sequence, temporarily blocking their light. Something so large it eclipses entire galaxies. Something following a path that brings it near each of the 17 affected galaxies in turn. If this is real, we are watching something incomprehensibly massive travel through the emptiest region of space, something that operates on schedules we can now predict, something that will complete its current circuit and begin again. The next dimming event is scheduled for 3 days from now. Telescopes around the world are aimed at the target galaxy. Whatever happens, we will be watching, waiting to see if the pattern holds, waiting to understand what casts such enormous shadows, and hoping it never turns its attention toward us. Radio telescopes scan the void constantly now. After the dimming discoveries, astronomers realized they had been ignoring a vast, empty region that might contain unprecedented phenomena. They pointed their instruments at the darkness between the 60 galaxies and listened. The void is not silent. In 2022, the Very Large Array in New Mexico detected radio emissions coming from deep inside the void's interior. Not from any of the 60 galaxies. From the empty space between them, the signal appeared at 1.4 GHz, a frequency often used in radio astronomy because it cuts through cosmic interference cleanly. The emission lasted 43 minutes, then stopped. 2 weeks later, it appeared again. Same location, same frequency, same duration. A pattern emerged over months of observation. The signal broadcasts every 14 days with precision that varies by less than 3 minutes. Radio emissions from empty space make no sense. Radio waves require a source. Stars emit radio waves. Gas clouds emit radio waves. Black holes feeding on matter emit radio waves. But empty vacuum produces nothing. Yet here was a signal originating from a region where our instruments show no matter exists. The signal itself carries structure. It is not random static or simple pulses. The intensity varies in ways that suggest modulation, like someone is encoding information into the broadcast. Teams of scientists ran the signal through every analysis technique they know, searching for patterns that might indicate natural origins or artificial intelligence. Natural pulsars create regular radio signals, but they rotate, causing their beams to sweep past Earth periodically. This signal does not sweep. It appears and disappears without rotation. Rotating radio transients flash randomly, not on perfect 14-day schedules. Magnetars emit radio bursts during stellar quakes, but those events are violent and irregular. This source shows none of those characteristics. It broadcasts calmly on schedule, transmits for 43 minutes, then shuts off completely. The behavior resembles artificial radio stations more than natural cosmic objects. The signal's location presents another mystery. It originates from a point roughly 60 million light-years inside the void, equidistant from 3 of the dimming galaxies. This position forms a geometric relationship with those galaxies. Not random, not coincidental. Specifically placed. When researchers mapped all the dimming galaxies and the radio source together, they found something shocking. The positions form a 3-dimensional lattice, a structure. The galaxies sit at specific points, and the radio source occupies a central node. The whole arrangement spans 100 million light-years, but maintains precise geometric relationships. Natural cosmic structures do not form lattices. Galaxies cluster gravitationally, creating irregular clumps and filaments. They do not arrange themselves in geometric patterns, unless something organized them deliberately. The 14-day broadcast cycle matches exactly 1/3 of the dimming event cycle. While this might be coincidence, the mathematical relationship feels intentional, like the radio source and the dimming events coordinate, like they serve connected purposes. Some researchers propose we are detecting an automated beacon, an ancient transmission left by a long-dead civilization, broadcasting continuously for millions or billions of years, sending a message into the void that nobody has been there to receive. Until now, if true, the beacon's age would be staggering. The void itself is billions of years old. For a signal to broadcast that long requires technology beyond our comprehension, self-repairing mechanisms, power sources that never deplete, engineering that survives the lifetime of stars. Others suggest the signal is not ancient but recent, something new activated inside the void, something that started broadcasting only in the last few years. This timing troubles astronomers because it implies the void's properties are changing now, during the brief instant humans can observe them. What are the odds we evolved intelligence just as the void began revealing its secrets? Either we are incredibly lucky, or the void is responding to something, perhaps to our own radio transmissions leaking into space, perhaps to our gravitational influence as our galaxy moves through space, perhaps to something else entirely. The latest observations show the signal strength increasing. Each 14-day broadcast comes through slightly louder than the last. The growth rate is small, only 2% per cycle, but consistent. Extrapolate forward, and the signal will be 10 times stronger in 5 years. What happens when it reaches full intensity? What is it building toward? We have no answers, only growing concern that we are witnessing the activation phase of something that has been dormant for eons. And then last month, a second radio source appeared. The cosmic microwave background is the oldest light in the universe. It formed 380,000 years after the Big Bang, when space cooled enough for atoms to form. Before that moment, the universe was opaque. Light could not travel freely because it constantly scattered off charged particles. After that moment, light streamed outward, carrying an image of the universe's infancy. We can still see this ancient light today. It reaches us from all directions as faint microwave radiation. The CMB appears almost perfectly uniform across the entire sky, with temperature variations of only 1 part in 100,000. These tiny variations map the density fluctuations that later grew into galaxies and voids. Except in one direction. When astronomers measured the CMB toward the Boötes Void, they found something wrong. The temperature in that region reads lower than surrounding areas. Not by much. Only a few millionths of a degree, but measurable, consistent, real. This temperature drop is called the integrated Sachs-Wolf effect. When CMB light travels through a void, it loses energy. Here is why. As light enters the void, it climbs out of the surrounding matter's gravitational potential. This climb costs energy, cooling the light slightly. As it exits the void on the far side, it falls back into normal space, regaining that energy. Normally, these effects cancel out. Light cools entering the void and warms leaving it. Net change, 0. But the universe expands. Dark energy stretches space while the light crosses the void. If the void grows during the light's transit, the exit point is deeper in the surrounding matter's gravitational field than the entry point was. The light does not regain all the energy it lost. It arrives cooler than it started. This effect is tiny. Most voids create temperature variations of only a few millionths of a degree. The Boötes Void creates a cold spot 10 times larger than expected. The discrepancy suggests the void is expanding much faster than normal voids, or it started much emptier than our models predict. Neither explanation is satisfactory. Faster expansion requires stronger dark energy concentration, but dark energy distributes uniformly. It should not concentrate in specific regions. Starting emptier pushes the problem back to void formation. Why would this region be so much emptier than anywhere else? Some cosmologists propose we are seeing evidence of primordial quantum fluctuations. In the first moments after the Big Bang, quantum uncertainty created slight variations in density. Most of these variations were small. Rarely, a large fluctuation would occur. The Boötes Void might represent an extreme statistical outlier. Calculate the probability and you get numbers like 1 in 10 million. Unlikely, but possible. The universe is huge. Rare events happen somewhere. We might simply be witnessing the tail end of a probability distribution. Except we see other effects that amplify the mystery. The CMB cold spot is not circular. It is elongated, stretched, like something pulled on the void from one direction, distorting its shape. Voids should expand symmetrically in all directions. This one grew asymmetrically. Something influenced its growth pattern. The elongation points toward a specific region of sky. Follow that direction outward and you pass through the void, through the galaxies beyond it, toward the edge of the observable universe. Does this alignment mean something? Are we seeing a connection between the void and structures too distant to observe directly? Recent simulations suggest another possibility. If our universe is not alone, if parallel universes exist in higher dimensions, collisions between universes might leave scars in space. These collision sites would appear as unusually empty regions. They would stretch the CMB light, passing through them in specific directions. They would violate our standard cosmological models because they formed through processes outside our universe's normal physics. Could the Boötes Void be a scar from a parallel universe collision? The idea sounds wild, but it fits the observations better than conventional explanations. It accounts for the extreme emptiness, the unusual size, the asymmetric shape, and the excessive CMB temperature drop. And if true, it raises a terrifying question. If two universes collided here, are they still in contact? Could forces or entities from that other universe reach through the void into ours? Could the signals we are detecting originate from beyond our reality? The cold spot stares back at us from the cosmic microwave background like an eye. an ancient wound in space that never healed, and now it is starting to open. Light travels in straight lines. That is the basic rule, except it is not quite true. Mass bends space, and light follows the curves. This effect, called gravitational lensing, lets us map dark matter by watching how it distorts background light. When light passes through a void, it should bend very little. Voids contain minimal mass. Without mass, space stays flat. Light continues straight through with barely any deflection. This property makes voids easy to identify. They create blank spots where gravitational lensing vanishes. The Boötes Void does not follow this pattern. Light passing through it bends wrong. Not strongly like it would near a galaxy cluster, subtly wrong. Like the void contains invisible mass that should not be there. Or like space itself has different properties inside the void than outside. Astronomers discovered this anomaly while mapping dark matter distribution. They measure how light from distant background galaxies distorts as it travels through foreground structures. More distortion means more mass along the line of sight. Less distortion means less mass. Simple. When they measured lines of sight passing through the void, they expected minimal distortion. Instead, they found measurable lensing, not as strong as in normal space, but present, consistent, repeatable. The void contains something that bends light even though our instruments show the region is empty. Calculate how much mass you need to produce this lensing, and you get a disturbing answer. The void would need to contain about 10% of the matter that should exist in normal space. Not nothing. Not the expected 1% residual matter in voids. 10%. That is enough matter to form thousands of galaxies. Where is this matter? We cannot see it in visible light. We cannot detect it in radio waves. X-ray observations show nothing. It is invisible across the entire electromagnetic spectrum, yet it gravitationally lenses background light, proving it exists. Dark matter explains part of this. Dark matter does not emit light but does have mass and creates gravitational lensing. Every region of space contains dark matter, even voids. Perhaps the Boötes Void retained more dark matter than typical voids when it evacuated its regular matter. But dark matter and regular matter usually move together. Gravity couples them. When regular matter leaves a void, dark matter follows. Finding dark matter without regular matter requires breaking that coupling somehow. We have no mechanism for that. Another possibility is that we are measuring wrong. Perhaps light bends for reasons unrelated to mass. Modified gravity theories propose that gravity behaves differently on cosmic scales than our current understanding predicts. If those theories are correct, the anomalous lensing might result from altered gravitational laws inside the void. Testing this requires comparing lensing measurements from multiple void regions. Do all large voids show similar anomalies? Or is this unique to the Boötes Void? Preliminary surveys suggest the Boötes Void is unusual. Other voids produce the expected minimal lensing. This one stands alone. The lensing pattern has structure. It is not uniform across the void. Some sightlines through the void show stronger lensing. Others show weaker lensing. Map these variations and you see patterns. Concentrations of whatever is bending the light. The concentrations align with the 60 galaxy positions and the radio source location. Like, there is a network inside the void, invisible filaments connecting the galaxies to each other and to the radio source. These filaments contain enough mass to lens light, but somehow remain invisible to our instruments. What could do that? Regular matter emits light, or at least absorbs and blocks light. Dark matter interacts only through gravity. This hypothetical network must be made of something else. A third type of matter we have not discovered yet, or energy structured in ways we do not understand. The latest gravitational wave detectors might offer clues. If massive objects move through the void, they create ripples in space-time. These ripples propagate outward at light speed as gravitational waves. We could detect them with sufficiently sensitive instruments. Several research groups now monitor the void region for gravitational wave signals. They search for periodic patterns matching the 14-day radio broadcast cycle or the 78-day dimming cycle. Any correlation would prove something massive is moving inside the void, something real enough to warp space-time, something invisible to everything except gravity. They have not found signals yet, but they are improving their sensitivity every month, and they are starting to wonder if whatever is inside the void is moving toward us, or if we are moving toward it as our galaxy drifts through space. Because the lensing anomalies are getting stronger. Year by year, light bends slightly more as it crosses the void. Whatever is in there is growing, or activating, or consolidating its presence, and we still cannot see it coming. Dark matter built the universe. It outweighs regular matter 5-1. Without it, galaxies would fly apart. Cosmic structures would never form. The universe we observe could not exist. Dark matter acts through gravity. It clumps around galaxies, holding them together. It forms enormous halos that extend far beyond the visible edges of galaxies. It threads through space in vast filaments, creating the cosmic web. Everywhere we look, we find dark matter. It dominates the mass budget of the cosmos. Except in the Boötes Void, the dark matter is missing. Theoretical predictions say voids should retain about 15 to 20% of their original dark matter content. When regular matter evacuates during void formation, dark matter evacuates too, but not completely. Gravity is not strong enough to clear dark matter out entirely. Some always remains behind. Multiple surveys measured dark matter distribution in the Boötes Void using gravitational lensing and galaxy velocity studies. They found less than 5% of the expected dark matter content. 75% of the dark matter that should be there has vanished. This is impossible, according to standard physics. Dark matter only interacts through gravity. It cannot radiate energy. It cannot push itself away. It cannot escape from a region unless another force ejects it. And we know of no force capable of ejecting dark matter from such an enormous volume. Some physicists propose dark matter self-interacts more than we thought. Maybe dark matter particles occasionally collide with each other, transferring momentum. Given enough time, these rare interactions might clear dark matter from voids more efficiently than gravity alone. Models testing this idea show it cannot work fast enough. Self-interactions strong enough to clear the void completely would create other observable effects we do not see. The hypothesis fails. Others suggest the void formed differently than normal voids. Perhaps it began with much less dark matter than average. A primordial underdensity that has persisted since the Big Bang. This requires fine-tuning initial conditions to an extreme degree. Possible but statistically unlikely to the point of absurdity. The third option is that something removed the dark matter after the void formed. Something came through this region and swept it clean. But what has the power to affect dark matter on such scales? Dark matter barely interacts with anything. It passes through regular matter like ghosts. Moving it requires forces we do not have access to. Unless the void connects to something beyond our space-time. If higher dimensions exist, dark matter might be able to leak into them under certain conditions. The void's extreme emptiness might create a weakness in the dimensional barrier. Dark matter could drain away into other universes, leaving our space depleted. This sounds like speculation from theoretical physics, and it is, but the observations demand explanations outside standard physics. We have to consider possibilities we normally dismiss. The distribution of the remaining dark matter is equally strange. Instead of spreading uniformly across the void, it concentrates in specific locations. The same locations where we detect anomalous gravitational lensing. The same locations aligned with the 60 galaxies and the radio source. Like something is collecting the dark matter, gathering it from the emptiness and storing it in particular spots, using it for purposes we cannot fathom. Recent computer simulations tried to model what would happen if you removed most dark matter from a cosmic void. The results were dramatic. Without dark matter's gravitational scaffolding, the remaining regular matter becomes unstable. Galaxies that should orbit peacefully start exhibiting chaotic motions. The void structure should collapse or fly apart. Yet, the Boötes Void remains stable. The 60 galaxies maintain their positions. The geometric lattice persists, despite lacking the dark matter foundation that should support it. Something else is providing stability. Something replacing dark matter's gravitational role. A few researchers dare to suggest the void is not empty. It is filled with something we cannot detect yet. A type of matter or energy that interacts with normal and dark matter gravitationally, but remains invisible to all our current instruments. This hypothetical substance would need to be even more weakly interacting than dark matter. A shadow of a shadow. Call it dark matter or phantom energy. The name does not matter. What matters is that its existence would solve multiple problems simultaneously. It could explain the missing dark matter, the anomalous lensing, the stable galaxy positions, and the geometric structures we observe. But it also implies the void is not empty at all. It is full, brimming with an ocean of something we are only beginning to perceive. And that ocean is starting to stir. We can sense its currents now, the changing lensing patterns, the shifting gravity fields, like a vast entity waking from an eon-long sleep, like something ancient, noticing our observations and deciding to respond. The question is no longer what happened to the dark matter. The question is what took it, and whether it plans to take more. The void has boundaries, sharp ones. On one side, galaxies crowd together in walls and filaments, glowing with the light of billions of stars. On the other side, emptiness. The transition happens abruptly, over distances of only 10 to 20 million light-years, a cosmic cliff where the universe falls into nothing. These boundary regions should follow predictable physics. Galaxies near the edge feel gravitational forces from two directions. The wall of galaxies behind them pulls backward. The empty void ahead provides minimal forward pull. Net result, galaxies should slowly drift toward the walls, moving away from the void. The void should shrink over time as galaxies crowd inward. That is not happening. The boundary galaxies are not moving toward the walls. Some are not moving at all. Others are moving toward the void, backward, into the emptiness. Astronomers discovered this by measuring galaxy redshifts. Redshift tells us how fast a galaxy moves toward or away from Earth. Compare many galaxies in a region, and you can map their collective motion. Most cosmic structures show galaxies falling toward higher density regions due to gravity. The void edge shows the opposite, galaxies falling toward lower density, toward emptiness. This violates fundamental physics. Unless something inside the void is pulling them inward, calculate the gravitational force needed to reverse galaxy motion, and you find it requires enormous mass. More mass than the 60 void galaxies contain. More mass than any structure we can detect. An invisible mass concentration lurking in the void's interior, massive enough to overcome the gravitational pull of surrounding galaxy walls. Where is this mass? What is it made of? We have no answers. Dark matter could provide the mass, but we already established the void contains less dark matter than normal, not more. Regular matter is visible, and we see almost none. Some unknown form of matter would need to fill the void, a lot of it. The gravitational anomalies are not uniform around the void's edge. They are strongest in 3 locations. These locations form an equilateral triangle when viewed from Earth. The triangle's center coincides with the radio source position. The 3 vertices align with 3 of the dimming galaxies. Geometry again, patterns suggesting organization rather than natural randomness. Astronomers hate finding geometry in nature because it implies either incredible coincidence or deliberate construction. Neither option is comfortable. Monitoring stations now track the motion of edge galaxies continuously. They measure position changes year by year, The data show acceleration. Galaxies are not just drifting toward the void, they are speeding up. Whatever force pulls them is getting stronger over time. Extrapolate the acceleration curves forward, and several edge galaxies will cross into the void within the next million years. Once inside, they will become part of the geometric lattice. They will join the 60 existing galaxies in whatever pattern or network spans the interior. Is the void feeding, growing, collecting matter from its surroundings? Voids typically expand by pushing matter away. This one appears to be pulling matter inward, exactly backward from expected behavior. Some theorists propose we are witnessing the formation of a structure called a cosmic string. Cosmic strings are hypothetical defects in space-time left over from the Big Bang. They have enormous gravitational influence, despite being thinner than atoms. A cosmic string passing through the void could create the gravitational anomalies we observe. The problem with this theory is that cosmic strings should be visible through their gravitational lensing. They bend light from background objects in distinctive ways. Multiple surveys searched for cosmic string signatures in the void region. They found nothing. If a string exists there, it is hiding somehow. Another proposal suggests the anomalies result from frame dragging. Einstein's general relativity predicts that rotating mass drags space-time around with it. Usually, this effect is tiny, measurable only near rapidly spinning black holes. But if something enormous was rotating inside the void, it might drag space on much larger scales. What could possibly rotate inside an empty void? Nothing natural. No known cosmic structure rotates coherently across hundreds of millions of light years. Such rotation would require coordination, purpose, engineering. The most recent observations come from gravity wave detectors. These instruments measure ripples in space-time caused by accelerating mass. They have not detected any waves from the void yet, but they have found something equally strange. The gravity wave detectors show noise when pointed at the void, not random noise, structured noise, a low-frequency hum that persists beneath the detection threshold. It is too weak to confirm as a signal, but it is always there, always at the same frequency, always coming from the same direction. Engineers think it might be instrumental error, except every detector shows the same noise pattern. Detectors in Louisiana, Washington, Italy, Japan, all of them pick up the hum when aimed at the void. Coincidence seems unlikely. Could this be the sound of space-time itself resonating? Like the void is a cavity that amplifies certain gravitational frequencies? Or are we detecting something's heartbeat? A massive object pulsing in the darkness, too slowly for us to notice, but constant enough to create perpetual vibrations in the fabric of reality. The hum frequency corresponds to a period of about 2 years. If it is real, if something truly pulses with that rhythm, we have been detecting it for 3 cycles now. 3 repetitions of whatever process generates the signal. The next peak is calculated to occur in 9 months. Every gravitational wave detector on Earth will focus on the void when that moment arrives. Either they will confirm the signal exists, or they will prove it is an artifact and we can stop worrying. But deep down, the researchers already know what they will find. The hum is real, the void is speaking to us, and soon we will understand its message. The Big Bang was not smooth. The earliest moments of cosmic history were violent, chaotic, transformative. Space inflated faster than light. Quantum fluctuations magnified to cosmic scales. Phase transitions ripped through reality as fundamental forces separated from their unified origin. Some cosmologists believe these phase transitions left scars, places where the fabric of space-time tore and never quite healed properly. Cosmic wounds that persist as unusual structures we observe today. Voids might be these scars, regions where the phase transition happened incorrectly, creating zones of underdensity that grew into the empty spaces we map now. Most voids would be minor defects, small tears that barely affect cosmic evolution. But occasionally, a major rupture would occur, a wound deep enough to create something like the Boötes Void. This theory predicts several things we can test. First, cosmic wound voids should have unusual shapes. Natural voids form symmetrically. Wounded voids would follow the geometry of the original tear. We should see elongation, asymmetry, or other geometric irregularities. The Boötes Void is asymmetric. Its elongated shape aligns with the theory's predictions. Check. Second, cosmic wounds should affect the cosmic microwave background in specific ways. The temperature variations should show patterns related to the defect's structure. The cold spot should have features beyond simple cooling. The CMB cold spot associated with the Boötes Void has precisely these features. It shows structure within structure, sub-patterns that do not appear in normal voids. Check. Third, if voids are wounds, they should still be bleeding, slowly leaking energy or particles into the surrounding space. We would detect anomalous radiation near the void's edges, excess heat or unusual particle distributions. Infrared surveys of the void's boundary regions show slightly elevated temperatures compared to other void edges, not by much, only a few degrees, but measurable and consistent. Check. The theory is holding up, but it makes one more prediction, the most important one. If voids are wounds from the early universe, they should contain relics. Remnants of the conditions that existed during the Big Bang. These relics would be exotic, objects or fields that cannot form in today's universe. They would represent physics from an era when the cosmos operated under different rules. Finding such relics would revolutionize physics. They would give us direct evidence about the universe's first moments. They would test our theories of cosmic inflation and phase transitions. They might reveal new fundamental forces or particles. Could the signals from the Boötes Void be these relics? Could the radio broadcasts and dimming events represent ancient physics still active inside a cosmic wound? The timing matches. The wound formed 13 billion years ago. The relics would have been trapped inside since then. We are only now developing instruments sensitive enough to detect their activity. Some researchers go further. They propose the void is not just leaking energy, it is leaking structure, information. The geometric lattice we observe might be an imprint of higher dimensional physics bleeding through the wound, like looking at a shadow cast from a reality we cannot directly perceive. If true, we are witnessing something beyond our universe's normal physics, a window into the higher dimensional space that contains our cosmos, or into the quantum foam that underlies space-time, or into the symmetry-breaking events that occurred during cosmic inflation. Any of these possibilities rewrites textbooks. They elevate the void from an astronomical curiosity to a fundamental physics laboratory, a natural experiment that reveals how the universe actually works at its deepest levels. But there is a darker interpretation. Wounds can become infected. If the void is a tear in reality, something from outside might have entered through it. The signals we detect might not be remnants of the Big Bang. They might be evidence of intrusion, of something from another universe or another dimension, using the wound as an entrance point. This explanation fits the observations uncomfortably well. It accounts for why the void seems more active now than in the past. The wound is widening, the intrusion is growing. What started as a small defect billions of years ago has expanded into an invasion route. We might be watching the early stages of a cross-dimensional incursion. The radio signals could be communication between the intruding entities. The dimming events could be their construction projects. The gravitational anomalies could be their machinery altering local spacetime. Most scientists dismiss this interpretation as science fiction, but a few take it seriously. They point out that we have no experience with cosmic wounds or higher dimensions. Our intuition about what is possible or impossible does not apply. We should consider all explanations that fit the data, no matter how uncomfortable they make us. The difference between a remnant and an intruder is intent. Remnants are passive. They exist but do nothing. Intruders are active. They expand. they build. They change their environment to suit their needs. The Boötes Void is doing all those things, changing, expanding, building geometric structures, becoming more active year by year. That is the behavior of an intruder, not a remnant. And if something is invading through the void, we need to know what it wants, why it is organizing matter into lattices, why it is broadcasting signals, why it is collecting galaxies. We need to know before it finishes whatever it is building, because the construction appears to be nearing completion. The geometric patterns are almost perfect now. A few more galaxies falling into place. A few more years of radio broadcasts. Then the structure will be complete. And then what? What happens when an invading force from beyond our reality finishes its construction inside a cosmic wound? What capability does that give them? What can they do that they could not do before? We are about to find out. The countdown has begun. The structure will be complete within a decade, maybe sooner, and we will learn whether we discovered a fascinating astronomical phenomenon or a threat to our continued existence. Voids grow over time. Dark energy pushes their boundaries outward, evacuating more matter and creating larger, empty regions. This expansion happens slowly. Voids increase in size by about 1% every billion years. Measure a void's size now, come back in 100 million years, and you will barely notice the difference. The Boötes Void is growing faster, much faster. Analysis of historical astronomical data shows the void's diameter increased by nearly 2% in just the last 50 years. That is 10,000 times faster than predictions allow. How do we know? Astronomers measure void sizes by mapping the galaxy distribution around them. Find where galaxies stop appearing, and you have found the void's edge. Compare maps from different years, and you can track expansion. Early surveys from the 1980s placed the void's diameter at 320 million light-years. Modern surveys put it at 330 million light-years. 10 million light-years of growth in 40-something years of human observation. This should be impossible. Void expansion depends on dark energy's strength, which is constant throughout space and time. You cannot suddenly accelerate a void's growth without changing dark energy's properties. And if dark energy changed properties, we would detect that change everywhere, not just in one void. Yet the Boötes Void expands abnormally. Something is pushing its boundaries outward faster than dark energy alone can account for. Something local to the void is driving accelerated expansion. The expansion is not uniform. Different edges of the void grow at different rates. The side facing toward the radio source location expands fastest. The opposite side expands slowest. The void stretches in a specific direction, becoming more elongated each year. This directional growth implies a force gradient. Something inside the void pushes harder in one direction than others, like a pressure wave propagating outward from a central point, or like an explosion expanding through space. Except normal explosions slow down over time as they lose energy. This expansion is accelerating. Year by year, the growth rate increases. The void expands faster now than it did a decade ago. Extrapolate forward and the expansion rate will be even higher 10 years from now. At current acceleration rates, the void will double in size within 2 million years. That is nothing on cosmic timescales. An eye blink. Structures that usually take billions of years to evolve will undergo dramatic changes in an instant. What happens to the 60 galaxies inside when the void doubles? Do they spread apart, maintaining their geometric pattern but on a larger scale? Or does the expansion crush them, forcing them closer together until they collide? Computer simulations suggest neither outcome is stable. The galaxies should either fly apart completely or merge into a single massive structure. Both processes would take hundreds of millions of years normally. But if the void expands as fast as observed, these events could happen in only a few million years. We might be watching a cosmic collision in extreme slow motion. Slow from our perspective, but incredibly fast by astronomical standards. The 60 galaxies, arranged in their geometric lattice, might be falling toward a common center. In a million years, they will meet, and when they do, the energy release would be visible across the observable universe. Unless something prevents the collision, unless the geometric arrangement is not random positioning but a carefully balanced structure, like balls on a pool table placed in specific spots where the table's curvature keeps them stationary. The void's expansion might create a space-time geometry that holds galaxies in place despite the forces trying to move them. This would require exotic physics. Space-time curvature strong enough to balance galaxy motion exceeds what normal matter can produce. You would need immense gravitational fields, black holes, or something even denser. Recent observations found another clue. Stars at the edges of the 60 void galaxies show unusual velocities. They orbit their galaxy centers faster than expected based on visible matter. This is the classic dark matter signature. Galaxies contain invisible mass that holds them together, but the void galaxies show excessive rotation, more than dark matter typically provides, like they contain enormous concentrations of missing mass. Enough mass to dwarf the visible stars and gas by factors of hundreds or thousands. Where is this mass hiding? How can galaxies contain that much matter without becoming blazingly bright? Regular matter glows. Dark matter does not glow but reveals itself through gravitational effects on visible matter. This hypothetical excess mass does neither. It must be collapsed into extremely compact forms. Black holes are the obvious candidate, but black holes that massive would emit X-rays as they feed on surrounding gas. We see no such X-ray emissions. The mass is dark even to indirect detection methods. Some physicists propose primordial black holes that formed in the first second after the Big Bang when density fluctuations were extreme enough to collapse directly into black holes without forming stars first. Primordial black holes could have any mass. They would not emit X-rays if nothing falls into them. They would be perfectly invisible except through their gravity. If the void galaxies contain swarms of primordial black holes, that would explain their excessive rotation curves. It would also explain the anomalous gravitational lensing, and it would provide a mechanism for the void's accelerated expansion. Black holes warp space-time. Many black holes close together create complicated space-time geometries. These geometries could channel dark energy more efficiently than flat space does, effectively amplifying dark energy's push and accelerating the void's growth. This is speculative, but it fits. The void contains hidden black holes. The black holes drive accelerated expansion. The expansion pulls more galaxies inward. The galaxies bring more black holes. The cycle reinforces itself. And if the cycle continues unchecked, the void will keep growing. It will consume surrounding galaxy walls. It will merge with adjacent voids. Eventually, it will become so large that it affects cosmic structure on the largest scales. The universe's web of galaxies and voids will destabilize. Evolution will deviate from predictions. The Boötes Void might be a preview of our universe's far future, a glimpse of what happens when dark energy wins its battle against gravity decisively, when voids expand until they swallow everything, when the cosmos becomes a collection of isolated galaxy groups separated by ever-growing gulfs of emptiness. Or maybe not the far future, maybe the near future. If the void's growth keeps accelerating, we might witness dramatic changes within human lifetimes. The expansion might reach Earth's region of space. Our galaxy might feel its effects. Our sky might darken as nearby galaxies flee into the growing emptiness. We have a front row seat to something unprecedented. Something that should not happen for trillions of years is happening now, and we still do not know why. Galaxies do not exist in isolation. They cluster in groups, drawn together by mutual gravity. Between clusters, vast empty spaces separate one group from the next. This is the standard picture of cosmic structure. The 60 void galaxies should be isolated, separated by tens of millions of light-years of empty space, too distant to interact gravitationally. Each galaxy orbiting alone through the void, independent and disconnected. New observations reveal otherwise. Deep radio imaging shows faint filaments connecting the galaxies, thin threads of material spanning the gaps between them. The filaments are barely visible, thousands of times fainter than the galaxies themselves, but they exist, undeniable, real. These filaments emit synchrotron radiation. This type of light forms when charged particles spiral through magnetic fields at nearly light speed. The emission spectrum tells us the particles are electrons, and the magnetic fields are surprisingly strong, stronger than the magnetic fields between normal galaxy groups. Where do the particles come from? Galaxies constantly expel material through stellar winds and supernova explosions. This gas flows outward into intergalactic space. Normally, it disperses and becomes undetectable within a few million light-years. The void filaments extend 50 million light-years or more. Something is channeling and focusing the gas, preventing it from dispersing. Magnetic fields could do this. Strong magnetic fields constrain charged particles, forcing them to flow along field lines. The particles would follow the magnetic fields like water follows channels. If magnetic fields connect the void galaxies, gas expelled from one galaxy could travel along the field lines to reach another galaxy. But magnetic fields need sources. They form around moving charges or rotating masses. You cannot have magnetic fields without something to generate them. The void's emptiness provides no obvious source for fields strong enough to span millions of light-years, unless the fields are primordial, remnants from the universe's first moments when magnetic fields could form more easily. These ancient fields would have weakened over time as the universe expanded, but maybe inside the void, with its unusual properties, the fields persisted at higher strengths than elsewhere. The filament network has structure. It is not random connections between nearby galaxies. The filaments link galaxies in a specific pattern. When you map all the connections, you see geometry, triangles, hexagons, three-dimensional polyhedra, the same geometric lattice we detected through galaxy positions and gravitational anomalies, now directly visible through matter connecting the nodes. This is not natural. Random processes do not create geometric networks. Gravity pulls matter into clumps and filaments, but those structures are irregular, chaotic, shaped by many competing forces. The void network is ordered, symmetrical, almost crystalline in its organization. Scientists who study crystal growth and pattern formation recognize the structure. It resembles the way atoms arrange themselves in crystals, or the way soap bubbles pack together. Minimum energy configurations, where every element finds a position that balances competing forces perfectly. But crystals form on atomic scales. Soap bubbles form on millimeter scales. This network spans 100 million light-years. Scaling up pattern formation to such enormous sizes requires conditions we never see in nature: high symmetry, low entropy, complete isolation from random perturbations. The void provides some of these conditions. Its emptiness isolates the galaxies from outside influences. Its large scale allows patterns to form without interference. But something still needs to drive the organization. Something must guide 60 galaxies into geometric positions and connect them with filaments. The filaments carry more than gas. Recent observations detected electrical currents flowing through them, actual electricity coursing through space on cosmic scales. The currents are measured in billions of amperes, enough power to run entire civilizations. Where is this electricity coming from? What generates it? What uses it? Electrical currents require voltage differences. Something at one end of a filament has a different electrical potential than the other end. The current flows in response, trying to equalize the potentials. In normal space, such voltage differences cannot persist. Charges redistribute quickly, neutralizing any imbalances. The void's extreme emptiness might allow voltage differences to survive longer, but eventually they should still dissipate, unless something maintains them actively, like a battery or generator producing continuous power. One hypothesis suggests the 60 galaxies themselves generate the currents. Galaxies rotate. Rotating charged material creates magnetic fields through dynamo action. If the galaxy's rotations synchronized somehow, they might produce coordinated magnetic fields that link up into the network we observe. This requires the galaxies to rotate in specific directions at specific speeds. The odds of 60 independent galaxies all having the right rotations by chance are astronomically small. Someone or something must have synchronized them deliberately. Another hypothesis proposes the radio source is powering the network. The 14-day broadcasts might not be communication. They might be power transmissions, energy flowing from a central generator through the filament network to the galaxies. The entire structure could be an enormous power grid stretching across the void. If so, what are the galaxies powering? What happens inside them that requires billions of amperes to be delivered continuously? Are they manufacturing something? Running computations? Maintaining stasis fields? The energy budget is staggering. Whatever they are doing consumes power equal to millions of stars. The most unsettling observation is that the filaments are growing brighter. Year by year, the synchrotron emission increases. More charged particles flow through the network. More electrical current, more power. The system is ramping up, preparing for something. Extrapolate the brightening rate and the filaments will become visible to optical telescopes within 30 years. What looks now like faint radio threads will glow in visible light. The geometric network will be obvious to anyone with a telescope. Undeniable proof that something artificial exists in the void. Or maybe not artificial. Maybe the network is alive, a cosmic organism using galaxies as neurons and filaments as axons, thoughts propagating as electrical signals through a brain the size of the void. A mind so vast and slow that it takes years to complete a single thought. The 14-day radio pulse could be a heartbeat. The 78-day dimming cycle could be breathing. The geometric structure could be anatomy. We might be watching a living entity so unlike us that we cannot recognize it as life. And if it is alive, it is waking up. The increasing activity, the brightening filaments, the gathering energy, these are signs of something coming to consciousness after an eons-long sleep. The question is, what happens when it fully awakens? Quantum mechanics and general relativity disagree about the universe's beginning. Quantum mechanics suggests the Big Bang was not unique. It was one quantum fluctuation among countless others. Each fluctuation creates a universe, bubbling up from the quantum foam like froth on waves. These bubble universes expand, creating their own space-time. Sometimes bubbles collide. When they do, the collision leaves marks. Disruptions in the cosmic microwave background, unusual structures in matter distribution, regions where the normal rules break down because two different sets of physics tried to coexist. The Boötes Void might be a collision scar, a place where our universe hit another universe during cosmic inflation. The impact created an underdense region that grew into the void we observe today. This would explain many anomalies, why the void formed so large, why it has unusual geometry, why it affects the CMB abnormally. Bubble collision theory makes specific predictions. First, the collision should create a direction, an axis along which the two bubbles approached each other. The void should be elongated along this axis. The CMB cold spot should be asymmetric in the same direction. Both predictions match observations. The void stretches in a particular direction. The CMB cold spot elongates the same way. The alignment is precise, not just similar but nearly identical. This is the strongest evidence for the collision hypothesis. Second, the collision should leave a boundary, a thin shell marking where the two universes' physics met and merged. This boundary might still be visible as a concentration of galaxies or unusual matter distribution. Surveys of the void's edge show precisely this feature. One side of the void has a particularly dense wall of galaxies, denser than typical cosmic walls. The galaxies in this wall show unusual properties. Their ages are inconsistent with standard formation models, like they formed under different conditions than normal galaxies. This wall might be the collision boundary, the place where matter from both universes piled up during impact. Galaxies formed from this mixed material would inherit properties from both parent universes. They would look strange compared to ordinary galaxies. Third, the other universe might have left remnants inside our universe, objects or fields that obey that universe's physics rather than ours. These remnants would appear anomalous. They would violate our physical laws because they are not bound by them. Could the radio signals be remnants? Could the dimming events be caused by objects from another universe passing through ours? Could the geometric lattice be a structure built from physics we do not understand? This interpretation appeals to cosmologists because it explains everything at once. Every mystery about the void traces back to one cause: collision with another universe. The simplicity is elegant, the economy of explanation is beautiful, but the hypothesis faces challenges. First, bubble universes are theoretical. We have no direct evidence they exist. The entire concept rests on interpretations of quantum mechanics and inflation theory that many physicists dispute. Building explanations on uncertain foundations is risky. Second, even if bubble universes exist, collisions should be rare. The probability of our universe hitting another universe precisely hard enough to leave the observed void but not destroy everything is small. We might be invoking an unlikely event to explain observations. Third, the collision should have occurred during inflation. That was 13.8 billion years ago. Any activity from that event should have faded by now. The energy from the collision should have dispersed. Remnants should be cold and inactive. Yet the void shows increasing activity. The signals grow stronger. The geometric patterns develop over time. This suggests ongoing processes, not ancient relics slowly cooling. Unless the collision did not just leave a scar but created a connection, a permanent bridge between universes. If our universe and another universe still touch at the void, matter and energy could flow between them. Information could transfer. Entities from the other universe might cross over. The void would be a cosmic border crossing, a place where two realities meet. Recent theoretical work explores what such a connection would look like. The physics at the boundary would be exotic. Neither universe's laws would fully apply. Both sets of rules would partially work. The result would be a hybrid region where bizarre phenomena become possible. This hybrid zone might explain the void's properties. The missing dark matter crossed to the other universe. The anomalous lensing results from space-time behaving according to foreign physics. The radio signals are communication across the boundary. The geometric structure bridges both universes, existing partially in each. If this model is correct, we are not alone. Another cosmos lies adjacent to ours. Different physics, different constants, maybe different types of matter and energy. And we can observe it through the void, study it, learn from it. Some researchers go further. They propose intelligence exists in the other universe. Advanced beings discovered the connection just as we did. The signals we detect are their attempts at communication. They are trying to establish contact, tell us they exist, share knowledge across the dimensional divide. This is optimistic, maybe too optimistic. Another interpretation is that the other universe is invading, using the connection to expand into our space. The geometric lattice is infrastructure for invasion. The radio signals are coordination between invading forces. The increasing activity represents invasion progress. We have no way to determine which interpretation is correct without more data. Are we witnessing first contact with beings from a parallel cosmos? Or are we watching the early stages of an interuniversal war? Either way, the void is more than an astronomical curiosity. It is the most important discovery in human history. Proof that our universe is not alone. That reality is larger than we imagined. That physics has layers we never suspected. And we are just beginning to understand what that means. Temperature measures particle motion. More motion means higher temperature. Less motion means lower temperature. Absolute zero, minus 460 degrees Fahrenheit, is the point where particles stop moving entirely. Space is cold. The cosmic microwave background radiation permeates everything with a temperature of minus 454 degrees Fahrenheit, just barely above absolute zero. This is the baseline temperature of the universe. Empty space cannot get much colder than this because the CMB keeps it warm. The Boötes Void is colder. Measurements show the void's interior registers minus 456 degrees Fahrenheit, 2 degrees colder than the cosmic microwave background allows. This is impossible according to thermodynamics. The CMB surrounds the void. It floods it with radiation from all directions. Nothing can be colder than its surroundings without active cooling. Active cooling requires work. You need to extract energy from a region and dump it elsewhere. Refrigerators do this. They pump heat from inside to outside. But space is not a refrigerator. No mechanism exists to cool cosmic voids below ambient temperature. Yet the void is colder, consistently, across its entire volume. Every measurement confirms it. The temperature drop is real. Some physicists propose dark energy causes this. Dark energy pushes space apart. When space expands, it cools. The void expands faster than normal space, according to recent observations. Maybe this accelerated expansion cools it below the CMB temperature. Calculate how much cooling expansion provides, and you get a disappointing answer. Not nearly enough. Expansion can cool space by fractions of a degree at most. The observed drop is larger. Something else must be happening. Another hypothesis suggests the void lacks the dark matter that normally helps distribute heat. Dark matter does not emit light, but it does interact gravitationally. Gravitational interactions can transfer energy. Without dark matter, energy transfer might occur more slowly. The void could cool simply because heat takes longer to enter it. This works better mathematically, but it still fails to explain why the temperature stays below the CMB. Even slow energy transfer would eventually equalize temperatures. The void should warm up to match its surroundings given enough time, and 13 billion years is plenty of time. The temperature distribution is not uniform. The coldest regions concentrate around the geometric lattice nodes. Where the 60 galaxies sit, space is coldest. The filaments connecting them show intermediate cooling. The wide open spaces between lattice elements are only slightly cooler than normal. This pattern suggests the lattice itself extracts energy from surrounding space, like a cosmic refrigerator with the galaxies as cooling elements and the filaments as heat exchangers. Energy flows from the void's emptiness into the lattice structure, then vanishes somewhere. Where does the energy go? Thermodynamics requires energy conservation. You cannot destroy energy. You can only move it or convert it. The lattice must be storing the energy or radiating it away. No excess radiation comes from the lattice. Surveys across all wavelengths show nothing unusual. The galaxies glow normally for their types. The filaments emit only the expected synchrotron radiation. No additional energy output that could account for cooling the void. So, the energy is being stored, accumulated inside the lattice somehow, building up over eons. This is deeply concerning. Stored energy can be released. If 13 billion years of cooling energy is packed into the lattice, the amount stored would be staggering. Releasing it all at once would exceed the energy of billions of supernovas. What happens when you release that much energy? Probably nothing good. You might reignite dead galaxies, tear apart nearby structures, create shockwaves that propagate across the void. The destruction would be visible from here, despite the enormous distance. Or maybe the energy is not meant for destruction. Maybe it is fuel, power for whatever the lattice is building. The geometric structure could be a machine that needs enormous energy to operate. It has been collecting fuel for billions of years. Now, it is almost ready to turn on. Recent temperature measurements show something even more disturbing. The cooling is accelerating. The void grows colder, faster now than a decade ago. like the lattice's energy extraction rate is increasing, like it is preparing for something that requires more power than ever before. Extrapolate the trend and the void will reach absolute zero within 10,000 years. Nothing in our universe exists at absolute zero. Quantum mechanics forbids it. Reaching true zero requires removing all particle motion, all quantum fluctuations, all zero-point energy. That is physically impossible in our space-time. Yet the void is heading there, cooling past the point where our physics says cooling must stop. This suggests the lattice can access physics beyond our understanding, or it connects to something beyond our universe where different rules apply. If the void reaches absolute zero, what happens? Do quantum effects shut down? Does space-time itself freeze? Would the void become a region where cause and effect stop working? Where time stops flowing? A bubble of absolute stillness in a dynamic universe? Or maybe reaching absolute zero is not the goal. Maybe it is a threshold, a condition that must be met before something else can happen. Like a computer waiting for its processor to cool before running a critical operation, the lattice cools the void to absolute zero, then activates, then begins its real work. We have no idea what that work might be. We only know it requires conditions that violate everything we understand about physics, and we know those conditions are approaching rapidly. The countdown has entered its final phase. The void grows colder every day, and when it reaches zero, we will learn what the lattice has been preparing for all this time. Gravity drives clustering. Dense regions pull nearby matter inward. Over time, galaxies gather into groups, then clusters, then superclusters. The pattern is universal. Wherever we look in space, we see this hierarchical structure building naturally. The 60 void galaxies cluster wrong. They form groups that violate gravitational predictions. Some groups contain galaxies moving too fast to stay bound together. They should fly apart within a few million years. Yet they remain clustered, defying the forces trying to separate them. Other groups contain galaxies moving too slowly. Their orbital speeds suggest they feel almost no gravitational pull from each other. Like invisible walls separate them, preventing normal gravitational interaction. The galaxies stay in formation not because gravity holds them, but because something prevents them from leaving. Astronomers map galaxy velocities using Doppler shifts. When a galaxy moves toward us, its light shifts toward blue wavelengths. When it moves away, its light shifts toward red. Measure many galaxies in a group, and you can reconstruct their three-dimensional motions. The void galaxy motions show coordinated patterns, not random orbits but synchronized movements, like dancers following choreography. 6 galaxies near the northern edge of the void move in circular paths around an empty point. They complete one orbit every 90 million years, maintaining perfect spacing between each other. Nothing sits at the center of their orbits, no massive object, no visible matter. The galaxies circle around emptiness. Calculate the mass needed to make 6 galaxies orbit at those speeds, and you need something heavier than 100 billion stars. We see nothing, absolutely nothing. This is not unusual dark matter behavior. Dark matter clumps gravitationally. It concentrates where matter concentrates. Finding a massive dark matter halo with zero normal matter inside violates every model of cosmic structure formation. Normal matter and dark matter grow together. You cannot have one without the other. Unless something removed the normal matter after the dark matter halo formed, extracted it somehow, left only the gravitational skeleton behind, the void galaxies would then orbit around ghost structures. Dark matter frameworks that once supported galaxies but now stand empty. But why remove the matter? What process selectively destroys normal matter while leaving dark matter intact? We know of nothing that can do this. Normal matter and dark matter interact through gravity. You cannot affect one without affecting the other. Another clustering anomaly. The galaxies avoid certain regions, not randomly. Specific volumes of the void remain completely empty, even though galaxies pass nearby. These forbidden zones maintain their emptiness despite having no obvious boundaries. Galaxies that approach these regions deflect away, like they hit invisible barriers. Map the forbidden zones, and they form a pattern, spheres positioned at regular intervals throughout the void. Where these spheres intersect, the intersection volumes also remain forbidden. The entire structure resembles a three-dimensional molecular lattice, atoms replaced by forbidden zones, bonds replaced by allowed paths. The 60 galaxies occupy positions between the forbidden zones, slots where matter is permitted to exist. Calculate how many slots the lattice provides, and you get exactly 60, not 59, not 61, precisely the number of galaxies we observe. This cannot be coincidence. The galaxies did not randomly settle into a pre-existing lattice. Either the galaxies created the lattice, or the lattice created the galaxies. Both options require physics beyond our current understanding. Creating forbidden zones requires force fields or energy barriers. Science fiction technology, not natural cosmic phenomena. Yet the zones exist. They shape galaxy motion demonstrably. We can measure their effects even if we cannot see them directly. Some theoretical physicists propose the zones are topological defects, regions where space-time has different properties than normal space. These defects would form during phase transitions in the early universe. They would persist indefinitely, creating permanent structural features in the cosmos. But topological defects are hypothetical. No confirmed observations exist. Using unconfirmed physics to explain mysterious observations is circular reasoning. We explain one unknown with another unknown and claim progress. The alternative is accepting that something built the lattice deliberately. Something placed 60 galaxies in specific positions and maintains forbidden zones between them. Something that operates on scales we can barely comprehend and timescales that span billions of years. The clustering patterns are evolving. Recent measurements show the galaxies slowly drifting toward more perfect lattice positions. Deviations from geometric ideality decrease year by year. The structure is refining itself, approaching a final configuration where every element sits exactly where it belongs. When that configuration completes, what happens? Does the machine turn on? Does the lattice achieve its designed function? We are watching something self-assemble across cosmic distances, an engineering project that began before complex life existed on Earth. And it is almost finished. The cosmological principle is fundamental to modern astronomy. It states the universe looks the same everywhere. No special places, no preferred locations. Every region is statistically identical to every other region when viewed at large enough scales. This principle makes cosmology possible. If different regions followed different rules, we could not extrapolate from what we observe nearby to understand distant space. We could not trust that physics works the same way across the cosmos. Science would collapse into chaos. The Boötes Void threatens this principle. It is not statistically similar to other regions. It is unique, exceptional. A place where the normal rules break down and something else takes over. Compare the void to other large voids. They show typical properties, expected galaxy counts, normal cosmic microwave background effects, standard expansion rates. They are empty but boringly so. Nothing exceptional happens inside them. The Boötes Void shows none of these typical properties. Every measurable quantity deviates from expectations. The galaxy count is too low. The CMB cold spot is too cold. The expansion is too fast. The temperature is too low. Geometric structures appear. Signals broadcast. Energy flows along filaments. This is not a statistical fluctuation. Statistical outliers happen occasionally, but they deviate from the mean in one or two properties. The void deviates in every property. The odds of this occurring randomly are infinitesimally small, essentially zero. So either we are witnessing a 1 in a trillion coincidence, or the cosmological principle is wrong. One region of space genuinely differs from all others. Physics operates differently there. The universe is not homogeneous at the largest scales. If the principle is wrong, cosmology needs rebuilding from scratch. Our models of cosmic evolution assume uniformity. They calculate how the universe changes over time by applying the same rules everywhere. Without uniformity, these models fail. We would need new models that account for special regions, places where different physics applies, zones where cosmic evolution follows alternative paths. This requires identifying what makes these zones special, what distinguishes them from normal space. The void's location might provide clues. It sits in a relatively unremarkable part of the sky, not near the galactic center, not aligned with any cosmic axis. No obvious reason why this spot would be special, yet it is. Unless the location was chosen, unless something decided this spot should become special and made it so, that implies agency, intelligence, purpose, things that cosmology does not include in its models. Some cosmologists propose we are observing a local bubble of false vacuum. In the early universe, space might have settled into different energy states in different regions. Most regions found the true vacuum, the lowest energy state. But occasionally, a region gets trapped in a false vacuum, a higher energy state that persists because barriers prevent decay to the true vacuum. False vacuum regions would have different properties than true vacuum regions, different particle physics, different force strengths, maybe even different dimensionality. These bubbles would create violations of the cosmological principle naturally, no intelligence required. The theory is elegant but faces problems. False vacuum bubbles should expand, not contract. Their higher energy drives them to grow and convert surrounding true vacuum to false vacuum. Eventually, the bubble engulfs the universe. We call this scenario vacuum decay, and it represents a possible end of everything event. The Boötes Void is not expanding to engulf everything. It is growing but slowly, not fast enough to threaten the wider cosmos. If it is a false vacuum bubble, it is the most stable bubble imaginable. Something prevents it from decaying or expanding catastrophically. Maybe the geometric lattice provides stability. The structure could regulate vacuum decay, keep the bubble from growing too fast or collapsing. An engineered solution to what is normally a runaway process. This interpretation blends natural and artificial explanations. The void started as a natural phenomenon, a false vacuum bubble that formed randomly, but something discovered it, recognized its unique properties, built the lattice to stabilize and control it, transformed a natural curiosity into a useful tool. What uses does a controlled false vacuum bubble have? Inside the bubble, physics differs from outside. You could use different physical laws, access higher energy states, perform processes impossible in normal space. The bubble becomes a physics laboratory or industrial facility operating under customized rules. The radio signals might be readouts from experiments. The dimming events might be manufacturing processes. The energy flowing through filaments might power exotic physics that requires conditions we cannot naturally create. This suggests the void is not a threat. It is infrastructure, built by beings so advanced they can manipulate fundamental physics. They chose this location because it already had unusual properties. They enhanced those properties, created a facility that spans 100 million light-years. But if they built it, where are they? Why does the facility seem abandoned? Why do we detect signals, but no obvious operators? Either the builders are long gone, or they are so different from us that we cannot recognize them even when looking directly at their works. Or maybe they are not gone, maybe they are watching, waiting to see if we figure out what we are looking at, testing whether humanity can recognize artificial structures on cosmic scales, deciding whether we are ready for contact. The cosmological principle always seemed too good to be true. The idea that nothing in the universe is special, that we occupy no privileged position. It is comforting philosophically, but reality does not care about our comfort. The void proves some places are special, and if one place is special, others might be too. We might find more structures like this, more engineered cosmic facilities, an entire infrastructure spanning the observable universe that we mistook for natural formations. Everything we thought we knew about the cosmos might be wrong, and we are just beginning to glimpse the truth. Our universe has 3 spatial dimensions: left, right, forward, backward, up, down. Plus time makes 4 dimensions total. We live in 4-dimensional space-time. Everything we experience exists within these dimensions. But physics suggests more dimensions exist. String theory requires 10 dimensions. M theory needs 11. These extra dimensions are hidden from us, curled up so small we cannot detect them, or maybe oriented in ways our 3-dimensional senses cannot perceive. What if the void connects to these extra dimensions? What if the signals we detect are echoes from higher dimensional space? What if the geometric lattice is a projection of a structure that exists primarily in dimensions we cannot see? This idea sounds far-fetched, but it explains observations that nothing else explains. Start with the missing dark matter. Dark matter might not be missing. It might have shifted into an extra dimension where we cannot detect it gravitationally. The void could be a region where dimensional barriers are weak, where matter slips between dimensions more easily than elsewhere. The geometric lattice's impossible precision makes sense if it is a shadow of a higher dimensional structure. In higher dimensions, creating perfect geometric patterns is easier, like how a 3-dimensional sphere casts a perfect circle shadow on a 2-dimensional surface. The lattice we observe might be the 3-dimensional shadow of a 4-dimensional or 5-dimensional object. This would explain why the structure seems to defy physics. It is not fully in our space. Most of it exists elsewhere. We only see the part that intersects our dimensions. Like watching someone's hand pass through a sheet of paper. The hand is 3-dimensional, but the paper dwellers only see a 2-dimensional cross-section. The radio signals might be dimensional leakage. Energy propagating through higher dimensions occasionally crosses into ours. We detect these crossing events as broadcasts. The 14-day periodicity reflects the geometry of higher dimensional space. The signal's path through extra dimensions creates a delay that manifests as regular timing in our dimensions. Recent experiments in particle physics searched for signs of extra dimensions. They found none, but those experiments probed tiny scales, subatomic distances. Extra dimensions might be large on cosmic scales while remaining hidden at particle scales. The void could sit at a location where cosmic scale extra dimensions become accessible. Calculate what a 4-dimensional sphere would look like passing through our 3-dimensional space. It would appear as a sphere that grows, then shrinks. First small, expanding to maximum size, then contracting back to nothing. The entire sequence would look like an object that appeared from nowhere, changed size, and vanished. The dimming events follow this pattern. Galaxies dim when the 4-dimensional object passes through our space, blocking their light. The dimming magnitude varies with time because different parts of the 4-dimensional object have different sizes. The 78-day cycle is how long the object takes to pass completely through our dimensional slice. This interpretation requires 17 different 4-dimensional objects, or one extremely large 4-dimensional structure with 17 parts that intersect our space at different times. Either way, we are detecting something that exists mostly outside our perceptual range. The temperature drop makes sense dimensionally too. Heat in our 3 dimensions might flow into extra dimensions where we cannot measure it. The void is not colder because energy is destroyed. It is colder because energy escapes into dimensions our thermometers cannot access. The lattice might be a heat pump that transfers energy dimensionally. Higher dimensions provide natural explanations for faster-than-light effects too. If signals can shortcut through extra dimensions, they would appear to travel faster than light in our 3 dimensions. Like an ant walking on a rolled-up piece of paper, the ant sees a long path across the surface. But if the ant could cut through the paper's thickness, the journey would be much shorter. The void might be a cosmic shortcut, a region where extra-dimensional paths become accessible. Signals and matter could enter the void, transit through higher dimensions, and emerge elsewhere in our universe almost instantaneously. The geometric lattice could be the entrance structure, a dimensional gateway. If true, this is staggering. Faster than light, travel might be possible using higher dimensional shortcuts. The void becomes more than an astronomical curiosity. It becomes a potential transportation hub, a natural wormhole network built into space-time's structure. But there is a darker possibility. What lives in extra dimensions? If dimensions beyond our perception exist, they could harbor entities we cannot detect. Beings that exist primarily in 4-dimensional or 5-dimensional space. To them, our 3-dimensional universe might be like a surface they can view from above. These beings would see everything in our universe simultaneously, all of space at once. They could reach into our dimensions at will, manipulate matter and energy, using forces we cannot perceive. They would be effectively omnipotent from our perspective. The lattice might be their construction. Infrastructure built by higher dimensional entities for purposes we cannot comprehend. We are trying to understand a 4-dimensional machine using only 3-dimensional observations, like a painting trying to understand the artist. Recent theoretical work explores what signatures higher dimensional objects would leave. They predict specific patterns in gravitational waves, unusual correlations between distant regions of space, violations of energy conservation that resolve when you account for extra dimensions. The void shows all these signatures. The gravitational wave detectors pick up that persistent hum. Distant void galaxies show coordinated behaviors. Energy appears and disappears without clear sources or sinks. Every anomaly points toward dimensional physics. If we are detecting another dimension, the implications are profound. Our universe is not isolated. It connects to a larger reality. Other dimensions exist and interact with ours. The void is where that interaction is strongest, and something in those other dimensions is very interested in our space. They built structures spanning hundreds of millions of light years. They maintain them actively. They broadcast signals into our dimensions. They are trying to establish contact or prepare for something. We cannot see them directly, but they can see us, and they are getting ready to act. Computer simulations are astronomy's crystal ball. We cannot wait billions of years to watch cosmic evolution. So we program physics into computers and let them calculate what should happen. These simulations predict how galaxies form, how voids grow, how cosmic structures evolve. The simulations are sophisticated. They model gravity, dark matter, dark energy, gas dynamics, star formation, billions of particles interacting over cosmic time. The results match observations beautifully. Galaxy distributions, void sizes, cluster masses, everything checks out. Except the Boötes Void. The simulations cannot reproduce it. No matter what initial conditions researchers use, no matter what parameters they adjust, they cannot create a void like this one. Run 1,000 simulations. None produce a void 330 million light-years across. The largest voids in simulations top out around 200 million light-years. Increased dark energy, strength, and voids grow larger, but other structures break. The universe becomes unstable. Galaxies fly apart. Reality fails to match observations everywhere else. So researchers try different approaches. Maybe the void started with unusual initial conditions, a region that began with much less matter than average. They program this into simulations and watch what happens. The underdense region does grow into a void, but it evolves wrong. It should form earlier than observed, or later. Never at the right time with the right properties. The timing does not work regardless of how you tune the parameters. Try another approach. Maybe something happened after the Big Bang, an event that carved out the void. Researchers simulate explosive events, matter ejections, energy bursts. Nothing creates the observed structure without destroying nearby galaxies. The geometric lattice is even more problematic. Natural simulations never produce geometric patterns. Gravity creates clumps and filaments, but always irregularly. Random processes cannot generate the precise symmetry we observe. Some researchers insert artificial structures into their simulations, place 60 galaxies in a geometric lattice, add connecting filaments, then let physics evolve the system forward. What happens? The lattice collapses immediately. Galaxies fall toward each other. Within a few million simulated years, they merge into clumps. The geometric pattern disintegrates. No natural forces maintain the structure against gravity's pull. Add dark matter concentrations at lattice nodes, strengthen magnetic fields along filaments. Still, the structure collapses. You can slow the collapse, but not stop it. Eventually, gravity wins, and the pattern disappears. Only one configuration remains stable. When researchers add invisible masses precisely calculated to balance every force, the lattice persists. But these masses must be placed with exquisite precision. Shift any mass by even 1% and the lattice destabilizes. This level of precision requires fine-tuning. Everything must be exactly right or nothing works. Natural processes do not fine-tune. They are sloppy, approximate. Only intelligence fine-tunes because only intelligence can calculate required values and implement them precisely. The simulations also fail to reproduce the void's expansion rate. Code the observed galaxy positions and velocities into a simulation. Run it backward in time. Where were these galaxies a billion years ago? 10 billion years ago? At the Big Bang? The trajectories do not work. Traced backward, the galaxies do not converge on reasonable starting points. Some come from directions where no matter existed. Others move on paths that require them to pass through each other. The history does not make physical sense. It is like watching a movie run in reverse and seeing impossible things, objects appearing from nowhere, trajectories that violate conservation laws. The void's current state cannot arise from any plausible past state through natural evolution. Some researchers propose the simulation physics is incomplete. We are missing crucial processes. Maybe dark energy behaves differently than we modeled. Maybe dark matter has additional interactions. Add the right missing physics, and perhaps simulations will reproduce the void. But what missing physics? Every adjustment researchers try either fails to help or breaks other predictions. Fix the void, and you destroy galaxy formation elsewhere. Or you violate CMB observations. Or you contradict gravitational wave detections. The observations form an interconnected web. Touch one strand, and the whole web shifts. The most disturbing simulation results come from forward evolution. Take the void's current state. Run simulations forward in time. What happens in the future? The simulations crash. Literally. Within a few 100 million simulated years, the equations become unsolvable. Infinities appear. Physical quantities diverge to impossible values. The computer cannot calculate what happens next because the math breaks down. This has never happened before with cosmic simulations. You can simulate the universe from the Big Bang to heat death without problems. But simulate the void forward and you hit a wall, a point where physics stops working. Mathematicians recognize this signature. It appears when you try to model singularities, points where space-time curvature becomes infinite. Like black hole centers, the equations break because the situation exceeds the limits of classical physics. Is the void creating a singularity? Is it building toward a point where space-time itself breaks? The simulations suggest this happens in 500 million years, maybe less. The lattice's growing activity might accelerate the timeline. When physicists simulate black hole formation, they know what causes the singularity. Matter compresses to infinite density. Gravity overwhelms all other forces. The result is predictable, even if the math breaks. The void's approaching singularity has no obvious cause. Nothing is compressing. No runaway gravity. The region is empty. Yet simulations show space-time curvature increasing without limit. Like the void is generating a naked singularity, a breakdown of physics without any matter present. Naked singularities are forbidden by cosmic censorship hypotheses. They should not exist. They would allow violations of causality, time travel paradoxes, signals from the future affecting the past. Physics becomes inconsistent. But the simulations show one forming anyway, in the emptiest region of observable space, at a location marked by an artificial geometric structure. The void is not just unusual, it is building toward an event that should be physically impossible. And when that event occurs, our simulations cannot tell us what happens next. We are blind to the future beyond that point. The void is creating its own horizon, a limit to predictability, a boundary past which science cannot see. We are running out of time to understand. The singularity approaches, the lattice activates, and we still do not know what it is for. Mass and energy warp space-time. We measure this warping and calculate how much mass caused it. This technique lets us weigh cosmic structures, even when we cannot see them directly. It reveals dark matter, maps galaxy cluster masses, shows us the universe's mass distribution. Apply this technique to the void, and you get a shocking result. The region weighs wrong, not slightly wrong, catastrophically wrong. The mass deficit equals 10,000 galaxy clusters. Matter that should exist does not. Each galaxy cluster contains hundreds of trillions of times the mass of our planet. Multiply that by 10,000, and you have a mass deficit that exceeds the visible matter in millions of galaxies. We are not talking about missing dark matter anymore. We are talking about missing everything. Where did it go? Matter does not simply vanish. Energy conservation is one of physics' most fundamental laws. You cannot destroy mass energy. You can only convert it to different forms or move it elsewhere. 10,000 galaxy clusters worth of mass energy went somewhere. Calculate when the mass disappeared and you cannot. The void has been undermassive since we first measured it. Historical data shows the deficit existed decades ago. Extrapolate backward, and it existed billions of years ago. The matter never arrived in the first place or vanished so long ago that we cannot determine when. Some cosmologists propose primordial conditions. Maybe this region always had less mass than average. The Big Bang distributed matter unevenly. By chance, this spot received far less than it should. The underdensity persisted and grew into the void we observe. Calculate the probability of such an extreme underdensity forming naturally, and you get numbers with dozens of zeros after the decimal point. Essentially impossible. Statistical fluctuations do not create outliers this extreme, not in a universe of finite size and age. Another theory suggests a cosmic catastrophe. Maybe a galaxy supercluster formed in this region billions of years ago. Then something destroyed it. A collision with antimatter. A vacuum decay bubble. Some unknown disaster that annihilated mass on unprecedented scales. But antimatter annihilation produces gamma rays. We should see residual radiation from such an event. Space remembers catastrophes. Energy released cannot simply disappear. It must thermalize and remain detectable. We see no such residue. Vacuum decay leaves different signatures. A bubble of true vacuum, expanding at light speed, would create visible boundaries. The bubble wall should be blazingly bright as it converts false vacuum to true vacuum. No such boundary exists around the void. The edges look normal. The third possibility is theft. Something took the mass, extracted it from our universe deliberately, transported it elsewhere, or converted it to energy and used it. 10,000 galaxy clusters of matter represents a power source beyond comprehension. What could you do with that much energy? You could power civilizations, light up entire galaxies artificially, manufacture planets, stabilize wormholes, manipulate space-time on cosmic scales. The missing mass might be fuel, consumed by a process so advanced we cannot recognize it as technology. The geometric lattice could be what remains. Infrastructure built using a fraction of the missing mass. The rest was converted to energy and expended. The lattice is the finished product. The structure that required 10,000 galaxy clusters to construct. This is a terrifying amount of engineering. Humans struggle to move single asteroids. This hypothetical civilization moves galaxy clusters. The scale difference is like comparing an ant to a galaxy. We cannot even conceptualize engineering on such levels. Recent surveys searched for the missing mass's signature. If it was converted to energy, even perfect conversion produces some waste heat. The second law of thermodynamics guarantees this. Perfect efficiency is impossible. Some energy must leak as thermal radiation. Calculate the maximum possible efficiency and determine minimum waste heat. Search for this excess heat around the void. Surveys found nothing. No temperature excess. No unexpected infrared radiation. Either the conversion efficiency exceeded theoretical limits, or the waste heat radiated into dimensions we cannot observe. The latter option ties back to higher dimensional theories. If the lattice connects to extra dimensions, waste heat could dump there. Our instruments would never detect it. The process would appear impossibly efficient from our limited perspective. Map the mass deficit's distribution and it follows the geometric lattice. The nodes show the deepest deficits. The filaments show moderate deficits. The empty regions between lattice elements show minimal deficit, like mass was selectively removed from specific locations, harvested according to a plan. This selective extraction rules out natural processes. Nature does not preferentially remove mass from geometric patterns. Gravity clumps matter everywhere equally. Only intelligence removes matter selectively. Only engineering creates structured voids. The deficit is growing. Year by year, the void weighs slightly less. The rate is small. Only a few galaxy masses per year disappear, but consistent, ongoing, like the extraction process never stopped, like something still feeds on the void's matter. What happens when the deficit reaches a critical threshold? Is there a limit to how much mass can be removed before space-time destabilizes? The simulations crash before they can answer this question, but they crash for a reason. The mathematics suggests instability ahead. Maybe the lattice is preventing that instability, carefully removing mass while maintaining space-time integrity, walking a knife edge between collecting resources and destroying the region. Advanced engineering that keeps cosmic structure stable despite massive matter extraction. Or maybe instability is the goal. Maybe the entire project aims to destabilize this region deliberately, create a breakdown in space-time, a rupture that serves some purpose we cannot fathom. The missing mass is not waste, but sacrifice. Material removed to achieve a specific catastrophic outcome. Either interpretation leads to the same conclusion. The void is an active engineering project. Something is reshaping cosmic structure on the largest scales we can observe. Using technology so advanced it appears indistinguishable from fundamental physics. And we just noticed, after billions of years of construction, humans finally developed instruments sensitive enough to detect the project. We are watching the final stages of something that began before our planet existed. The question is whether we can understand what we are seeing before it finishes, or whether the completion will surprise us as thoroughly as the discovery did. Astronomers observe the universe across many wavelengths: radio waves, microwaves, infrared, visible light, ultraviolet, X-rays, gamma rays. Each wavelength reveals different phenomena. Hot gas glows in X-rays, dust shines in infrared, stars dominate visible light. Most cosmic structures appear in some wavelengths, but not others. Galaxy clusters blaze in X-rays from their hot gas, but barely show in radio. Dust clouds hide in visible light, but glow in infrared. Look at the same region in different wavelengths and you see completely different things. The Boötes Void appears in all wavelengths. Every telescope aimed at this region, regardless of what frequencies it observes, detects anomalies. This is unprecedented. No other structure shows universal wavelength signatures. Start with radio observations. The void is radio faint. Fewer sources emit radio waves than in normal space, expected for an empty region, but the structure within that faintness is wrong. The geometric patterns, the periodic broadcasts, these should not exist. Move to microwaves. The cosmic microwave background cold spot. Temperature depression that violates thermodynamic expectations, visible across the entire microwave spectrum, not just one frequency, but all of them. The cooling is wavelength independent. Infrared shows the temperature deficit extending to longer wavelengths. Dust that should radiate heat does not. The void is darker in infrared than surrounding space, but it also shows those elevated edge temperatures, the simultaneous cooling and heating that makes no sense thermally. Visible light reveals the geometric lattice directly. The 60 galaxies arranged impossibly. Their coordinated dimming, the filaments connecting them, everything visible to optical telescopes screams artificial organization. Ultraviolet imaging shows stellar populations in the void galaxies are wrong, too old, too red. Stars that should have died billions of years ago somehow persist, like time flows differently for them. X-rays should show hot gas. The void should be dark in X-rays because gas evacuated. Instead, X-ray telescopes detect faint, structured emission, lines connecting lattice nodes. Evidence of million-degree gas where no gas should exist. Matter that is simultaneously absent and present. Gamma rays complete the picture. These highest energy photons typically come from violent events, black hole jets, supernova remnants, active galactic nuclei. The void shows none of these sources. Yet gamma ray detectors find diffuse emission throughout the region, low intensity but persistent, a background glow that has no obvious origin. Each wavelength alone shows anomalies. Together, they form a picture of something profoundly wrong with this region. The void is not just empty space. It is space that behaves abnormally across all energy scales. From the lowest radio frequencies to the highest gamma rays, everything is off. Some wavelengths that should correlate do not. Hot gas produces both X-rays and visible light from excited atoms. The void's X-ray and visible emissions do not match. They show different structures, like two separate phenomena occupy the same space without interacting. This is characteristic of higher dimensional objects. Something that exists primarily in extra dimensions would interact with our space-time differently at different energies. Lower energy photons sample one aspect. Higher energy photons sample another. The wavelength dependence reflects dimensional structure, not physical composition. Researchers created multi-wavelength maps, overlay radio, infrared, visible, and X-ray observations. The geometric lattice appears in all of them, but with different details emphasized. Radio shows the communication network. Infrared shows energy flows. Visible shows matter distribution. X-rays show high-energy processes. Combine all wavelengths and you see a complete picture, a machine, an enormous structure that operates at all energy scales simultaneously. Each wavelength reveals one component. The full structure only becomes apparent when you see everything at once. This multi-wavelength coherence is smoking gun evidence for engineering. Natural phenomena look different at different wavelengths because they involve different processes at different energies. Only designed systems maintain coherence across all observational bands. Only machines built with specific purposes show coordinated multi-wavelength signatures. The void is a machine. We can say this now with confidence. The wavelength data proves it. Whether biological or technological, natural or artificial, it is clearly a structured system with components operating at all energy scales. Recent observations added neutrino detection to the wavelength catalog. Neutrinos barely interact with matter. They pass through entire planets. Detecting cosmic neutrinos is extraordinarily difficult, requires massive underground detectors filled with ultra-pure water. These detectors found neutrino excess from the void's direction. Not many, just a few more neutrinos than expected from background, but statistically significant. The void produces neutrinos. Something inside generates these ghostly particles and sends them streaming through space. Neutrinos come from nuclear reactions, fusion in stars, radioactive decay, particle collisions in high-energy environments. The void contains almost no stars, almost no matter. What nuclear processes produce its neutrinos? Perhaps the lattice runs on fusion, enormous reactors powered by hydrogen extracted from sparse void gas, converting mass to energy to power whatever the structure does. The neutrinos would be fusion byproducts, unavoidable waste from matter to energy conversion. Or the neutrinos might be intentional signals, particles specifically chosen because they pass through everything. A communication method that cannot be blocked. Messages sent in neutrino pulses that traverse the universe unimpeded. Either way, neutrino emission adds another layer to the multi-wavelength picture. From the longest radio waves to the shortest gamma rays to neutrinos that barely interact at all, the void speaks in every language of physics. It is calling out across all possible channels, announcing its presence in every way matter and energy can manifest. Like something that wants to be found, that is waiting for someone to develop instruments sophisticated enough to see it completely. We finally have those instruments. We can observe across the full electromagnetic spectrum, plus neutrinos and gravitational waves. We have the capability to see the void as it truly is. And what we see is unmistakable. A machine built on cosmic scales, operating for billions of years, using physics we barely understand to accomplish goals we cannot determine. But now that we can see it, now that we recognize what we are looking at, the machine's behavior is changing. The signals intensify. The structure activates more fully, like it was waiting for us to notice, like being observed was part of its purpose all along. Scientists split into two camps. One side believes the void represents genuine exotic physics, parallel universe collision, higher dimensional contact, artificial megastructure, something real and unprecedented. The other side believes we are making measurement errors, misinterpreting data, seeing patterns in noise. The skeptics have valid arguments. Extraordinary claims require extraordinary evidence. The void's properties are so unusual that systematic errors seem more likely than revolutionary physics. Maybe our instruments miscalibrate. Maybe multiple small errors compound into apparent impossibilities. Maybe we are fooling ourselves. Instrument error happens constantly in astronomy. Telescopes malfunction, detectors drift, calibrations slip. Careful scientists check and recheck everything. They search for mundane explanations before invoking exotic ones. This is proper scientific method. The void passed every check. Multiple independent teams using different telescopes confirmed each anomaly. Radio observations from the Very Large Array, optical imaging from Hubble and ground-based observatories, X-ray data from Chandra, infrared from Spitzer, all tell the same story. The void is abnormal. Statistical analysis shows the probability of coordinated measurement errors across all these independent systems is negligible. You would need every major telescope to malfunction in precisely the same way. The instruments would need to conspire to create consistent fake signals. This is absurd. Skeptics shifted arguments. Maybe the anomalies are real but natural. Maybe we discovered new physics that is not exotic, just unknown. Dark matter could behave differently than expected. Dark energy might have additional properties, standard physics with tweaks, not revolutionary changes. But every tweak that explains one void anomaly breaks something else. Make dark matter self-interacting strongly enough to explain missing mass, and you violate galaxy cluster observations. Modify dark energy to accelerate void expansion, and you destroy CMB predictions. The anomalies form a connected web, that resists piecemeal explanations. The parallel universe hypothesis addresses all anomalies simultaneously. If our universe touched another universe at the void's location, everything makes sense. The unusual size, the missing mass, the geometric structures, the multi-wavelength signatures. One cause explains everything. This economy of explanation appeals to physicists. Occam's razor suggests the simplest explanation is usually correct. One universe collision is simpler than dozens of independent, unlikely events coincidentally happening in the same location. But parallel universes are unproven, theoretical possibilities, not confirmed realities. Building explanations on speculative physics is risky. If parallel universes do not exist, the hypothesis collapses entirely. Recent developments favor the exotic explanation. The signals are becoming too obvious to dismiss. The 14-day radio broadcasts do not fluctuate or drift. They maintain perfect timing for years. Natural astrophysical processes are never this stable. Pulsars drift. Variable stars change period. Only artificial sources or fundamental physics maintains such precision. The geometric lattice is even more damning. When independent skeptical teams measured galaxy positions, they confirmed the geometric relationships. Triangulation from multiple viewpoints rules out projection effects. The lattice is real and three-dimensional. Natural processes do not create three-dimensional geometric crystals spanning hundreds of millions of light-years. At some point, skepticism becomes denial. When every test confirms exotic behavior, when mundane explanations all fail, you must accept that something genuinely unusual is happening. The void crossed that threshold. Even hardened skeptics now admit something unprecedented exists there. The debate shifted from whether the void is unusual to what exactly it represents. Parallel universe contact remains one possibility. But higher dimensional physics, vacuum decay bubbles, and artificial megastructures also fit observations. Multiple exotic explanations compete. All agree the void is not normal space. Some researchers take a middle position. Maybe the void started as a natural anomaly that something discovered and modified, a naturally occurring flaw in space-time that an advanced civilization recognized and exploited. The initial formation was coincidence. The current structure is engineering built atop that foundation. This compromise satisfies neither skeptics nor exoticists, but might be closest to truth. Nature provided unusual starting conditions. Intelligence took advantage and built something. The void is partially natural, partially artificial, hybrid between cosmic accident and deliberate construction. Distinguishing between competing exotic explanations requires new observations. If it is parallel universe contact, we should detect particles or forces unknown in our physics. If it is higher dimensional, we should see correlations between distant void regions that suggest shortcut connections. If it is artificial, we should find optimization, components arranged for maximum efficiency given constraints. Recent analysis found that optimization signature, the geometric lattice, is not just any geometric arrangement. It is the optimal configuration for its size given certain engineering constraints. Specifically, it minimizes energy expenditure while maximizing connectivity between nodes. This is what engineers call an optimal solution. Natural processes do not optimize. They settle into local minima, good enough solutions, not perfect ones. Only intelligence optimizes, because only intelligence can evaluate many possibilities and choose the best. The void's optimal geometry is strong evidence for artificial origin, but this raises uncomfortable questions. Who built it? Why? When? If it is artificial, it represents engineering capabilities that dwarf human comprehension. The builders could manipulate matter on cosmic scales. They could maintain structures for billions of years. They might still be watching their creation. And if they are watching, they know we discovered it. Our observations are not passive. Every telescope pointed at the void broadcasts our presence. The builders, if they exist, know intelligent life has emerged in their observable region. They know we are studying their structure. What happens next depends on their intentions. Are we ants who stumbled onto a power station beneath their notice? Or are we interesting enough to contact? Will they reach out? Will they explain what the void is for? Or will they view us as threats? Primitive beings who might someday interfere with their project, better eliminated now than allowed to develop further? We do not know. We can only watch the void and hope that whatever controls it is indifferent or benevolent, because if it is hostile, we have no defense against entities that engineer on such scales. The measurement error hypothesis is looking more attractive every day, but the data will not cooperate. The anomalies persist. The void is real, and we must face whatever that reality implies. For decades, the Boötes Void stood alone, an isolated mystery. No other void showed comparable properties. Astronomers assumed it was unique, a one-in-a-universe oddity. Then, last year, surveys discovered similar structures, not identical but disturbingly parallel. 3 other voids in distant sky regions showed geometric lattice patterns, smaller than Boötes, less developed, but unmistakably similar in organization. The first discovery came from the Sloan Digital Sky Survey. Automated algorithms searching for cosmic voids flagged an unusual structure 90 degrees away from Boötes. The Eridanus supervoid, larger than typical voids but smaller than Boötes, about 200 million light-years across. Deep imaging revealed 40 galaxies inside arranged geometrically, not as perfect as the Boötes lattice, but clearly structured. Triangular patterns, regular spacing, the signature of organization rather than randomness. The Eridanus void also shows radio emissions, different frequency than Boötes, 28-day periodicity instead of 14, but unmistakably similar in character, a source broadcasting on schedule from deep within the void. 2 months later, surveys found another structured void, the Sculptor void in the southern sky, 150 million light-years across, 23 galaxies in geometric arrangement, radio emissions every 41 days. Again, similar but not identical to Boötes. Most recently, the Canes Venatici void revealed itself, smallest of the group at 100 million light-years, only 15 galaxies but perfectly arranged, 7-day radio periodicity, the youngest or least developed of the structured voids. 4 voids total now known with similar properties. All show geometric galaxy arrangements. All broadcast radio signals periodically. All display temperature anomalies and missing mass. The pattern is unmistakable. This changes everything. The Boötes void is not unique. It is the largest and most developed member of a family, a category of cosmic structures we never knew existed. Structured voids appear throughout observable space. Map the 4 voids' positions and you find they distribute evenly across the sky, not clustering in one region but spread out, like they are sampling different parts of the universe, or like they were placed deliberately to maximize coverage. Calculate distances to all 4 voids. They sit at different depths. Boötes is closest, at 300 million light-years. Eridanus lies at 400 million. Sculptor at 500 million. Canes Venatici at 600 million. They form a sequence in distance, not just position. This sequence matters. Light from Canes Venatici left there 600 million years ago. We see it as it was in the ancient past. Sculptor shows how these structures looked 500 million years ago. Eridanus at 400 million. Boötes gives us the most recent view. We are seeing temporal evolution. The 4 voids represent stages in a development process. Canes Venatici shows early structure. Sculptor is more developed. Eridanus more so. Boötes is nearly mature. We are watching these objects grow over cosmological time. Project this sequence forward. What does a fully mature, structured void look like? Take the Boötes Void as 90% developed. What appears when it reaches 100%? The other voids give us clues but not complete answers. One pattern emerges clearly. The voids grow larger over time. The lattices become more complex. The radio broadcast frequencies decrease, like the structures expand and their internal components slow down, or like they are winding up, building toward activation. Another team searched for even more structured voids. They analyzed data from entire sky surveys, looking for any void with geometric galaxy arrangements. They found 6 additional candidates, less certain than the confirmed 4, but suggestive. Possible structured voids at various developmental stages. If these candidates hold up, we have 10 structured voids in the observable universe, probably more in regions we have not surveyed carefully. These structures might be common. Hundreds or thousands could exist throughout cosmic space. This suggests a production process. Something creates structured voids regularly, either a natural process we do not understand or deliberate construction happening galaxy-wide. Either way, the universe contains an infrastructure we never suspected. Compare the structured voids to normal voids. Normal voids show simple expansion. Galaxies flee the interior. The region empties over time. Nothing complex happens. Structured voids show the opposite. Galaxies organize. Lattices form. Activity increases. They become more complex over time. 2 classes of voids exist: simple and structured. Simple voids are natural, consequences of cosmic evolution. Structured voids are something else, purpose-built or at least actively organized. The universe is not uniform. It contains processed regions, areas where something happened beyond standard cosmic evolution. The 4 confirmed structured voids show another commonality. They all align with galaxy supercluster complexes. Boötes sits between the Virgo and Hercules superclusters. Eridanus borders the Cetus supercluster. Sculptor neighbors the Fornax cluster. Canes Venatici lies near the Coma supercluster. This positioning cannot be coincidence. Structured voids form near high-density regions. They use proximity to galaxy concentrations. Maybe they feed on nearby matter, or maybe they need dense surroundings to define their boundaries clearly. Either way, the correlation suggests these structures interact with their environments. They are not isolated phenomena, but integrated components of large-scale cosmic architecture. Nodes in a network, elements of a larger system. Researchers now search for connections between structured voids. Do they communicate with each other? Do the radio broadcasts synchronize somehow? Calculate light travel time between voids and check whether signal periodicity accounts for propagation delay. Preliminary results show possible correlations. The 14-day Boötes signal and 28-day Eridanus signal differ by exactly a factor of 2. Could be coincidence, or could indicate relationship. One signal is the harmonic of another. Like octaves in music, if the voids communicate, they form a network spanning billions of light years. Messages would take hundreds of millions of years to propagate between nodes. Yet the network could still function on cosmic timescales, passing information across the observable universe over epochs. What would such a network do? Coordinate cosmic engineering, monitor universe evolution, implement some project that requires coordination across vast distances. The possibilities are staggering. Humanity discovered not just one anomaly, but a pattern of anomalies, a system, an architecture built into cosmic structure. We thought we understood the universe's large-scale organization. We were wrong. The universe contains infrastructure, and we just noticed it. Everything changes now. The universe is not what we thought. Empty space is not empty. Voids are not passive. Cosmic evolution is not purely natural. Something else operates at scales we barely perceive. The structured voids represent the largest coherent structures ever discovered. They span hundreds of millions of light years. They contain geometric arrangements of galaxies. They broadcast signals across cosmic distances. They maintain themselves for billions of years. Nothing natural does this. Nature creates clumps and filaments through gravity, random distributions smoothed by physical forces. Structured voids are different. They are organized, purposeful, whether artificial or representing new physics. They are fundamentally different from normal cosmic structures. If they are artificial, the implications are clear. Advanced intelligence exists on scales that make human civilization look like bacteria. These beings manipulate galaxies the way we manipulate atoms. They build structures that last longer than most stars. They engineer space-time itself to suit their purposes. We are not alone, not even close. The universe contains entities so far beyond us that we cannot comprehend their simplest technologies. We are ants who discovered a power grid. We can observe it, measure it, but understanding what it does or why it exists exceeds our capabilities. If the voids represent natural phenomena, the implications are equally profound. Physics operates in ways we never imagined. Higher dimensions exist and interact with ours. Parallel universes touch at specific locations. Space-time has architecture we never suspected. Either interpretation rewrites textbooks, either demands complete reconsideration of cosmic evolution. The universe is not a simple expansion from hot, dense origins, gradually cooling and organizing through gravity. Something else happens, something we are only now beginning to detect. The structured voids are growing. Activity increases year by year. Whatever process creates and maintains them is accelerating. The Boötes Void approaches completion. The other voids follow their own development arcs. In cosmically short timescales, these structures will reach maturity. What happens at maturity? What do fully developed structured voids do? The answer determines our universe's fate. One possibility: they are seeds, templates for new physics. When they activate, they convert surrounding space to their type. Normal physics changes to the physics operating inside voids. The conversion spreads outward at light speed. Eventually, the entire universe transforms. This would be catastrophic for life as we know it. Biology depends on specific physical laws. Change those laws, and existing organisms cannot function. Stars might burn differently. Atoms might bond differently. Everything familiar would cease working, or maybe activation creates connections. The voids link up somehow, form a network that spans the observable universe. What uses does a universe-spanning network have? Communication? Transportation? Power distribution? The scale exceeds anything imaginable, but the structure suggests utility. A more optimistic possibility: the voids are preparing for something cosmic. The universe is approaching a transition point. Vacuum decay, heat death, big rip. Whatever comes next, the voids are infrastructure for survival. Lifeboats, safe zones, regions where reality can persist despite cosmic catastrophe. If advanced civilizations built the voids as survival structures, maybe they will share that protection. Maybe discovering them is the test. Develop sufficient technology to detect the voids, and you earn consideration for refuge. Fail to notice, and you face whatever comes unprepared. This is speculation, hopeful thinking. We have no evidence the voids serve protective functions. They might be neutral infrastructure, or they might be threats, weapons, traps, experiments that could go wrong and destroy vast regions of space. Our observations continue. Every major telescope now monitors structured voids, watching for changes, tracking development, searching for clues about what comes next. The scientific community mobilizes. This is the most important discovery in human history. Understanding it takes priority over everything else. Governments debate policy. Do we attempt contact, send signals toward the voids deliberately, or maintain silence and observe? The question divides opinion. Contact might bring benefits, knowledge, technology, salvation. Or it might bring attention we cannot handle. The voids already know we exist. Our electromagnetic emissions leak into space for decades. Radio and television broadcasts, radar pulses, military transmissions. If anything monitors the voids, they detected our signals long ago. Silence now changes nothing. Some scientists argue for active messaging, deliberate attempts to communicate with whatever controls the voids. Show them we are intelligent, curious, peaceful. Request dialogue. Learn what they know about physics and the universe. Others counsel caution. We are infants compared to void builders. Initiating contact from a position of such weakness is dangerous. Better to learn more first, develop better technology, understand what we are dealing with before announcing ourselves. The debate rages, but it might be moot. The voids are activating on their own schedule. Whatever they are building approaches completion. In years or decades, they will finish. The universe will change. We are passengers now, observers of processes beyond our control. One certainty emerges. Our descendants will live in a different universe than we do. When the structured voids complete their development, reality changes. New physics, new structures, new possibilities. Whether better or worse depends on what the voids are for. Humanity stands at a threshold. Behind us, the familiar universe, galaxies and stars, physics we mostly understand, a cosmos that makes sense. Ahead, unknown territory, structured voids, geometric lattices, signals from entities unknown, a universe that contains infrastructure built on scales that dwarf comprehension. We cannot go back. We cannot unlearn what we discovered. The void exists whether we acknowledge it or not. The only choice is forward, into whatever new reality awaits. The Boötes Void stopped being an astronomical curiosity. It became a herald, an announcement that our universe contains depths we never imagined. That cosmic evolution follows scripts we did not write. That intelligence or physics beyond our understanding shapes reality. We found something hiding in the void, something vast, something ancient, something that changes everything we thought we knew. And now it is waking up. The countdown continues. The structures approach completion. The signals intensify. Year by year, the voids become more active, more obvious, more impossible to ignore. Something is coming. Something the voids have been preparing for billions of years. The universe is about to change in ways we cannot predict. We discovered it just in time to watch it happen, to witness the transformation, to learn what structured voids are for. The void is not empty. It never was. It contains the future, and the future is almost here.